Sir, at the outset, on behalf of Department of Civil Engineering, Amity School of Engineering and Technology, Amity University, Noida, and the entire Amity universe, we would like to welcome you to this keynote address on geotechnics and geosynthesis. For the benefit of participants who are listening to this talk, would like to let them know that Dr. Sanjay Kumar Shukla sir is associated with us for past more than 5 years, and he has been one of the guiding light for us. More importantly, when it comes to our international conference, his contribution in terms of being the editor of proceeding, the joint editor of our proceeding has been tremendous, and kind of review, the kind of paper, the extent of contribution in terms of letting the audience, more and more audience globally know about this conference. I would like to express my sincere appreciation for sir for being such a great support, and he has always been pushing us to reach out to a next level of excellence, and that is something that we really appreciate. So we always start believing in ourselves when you say that you can do it more better, and that's the particular endeavor with which we have been trying to improve year on year, conference after conference. And I think all the speakers and the supporters would be testimony to it. Dr. Sanjay Kumar Shukla sir is founder editor-in-chief of International Journal of Geosynthetics and Ground Engineering, Springer Nature, Switzerland. He is also founding research group leader of Geotechnical and Geoenvironmental Engineering at School of Engineering, Edith Cowan University of Australia. He is adjunct professor. I mean, the list can keep going on and on to name a few. Adjunct professor, Department of Civil Engineering, Indian Institute of Technology, Chennai. And to just add on, he is honorary professor of Department of Civil Engineering, which was conferred to him in the last conference. And since then, I mean, not even since then, I would say years before that, he had been a great support and a guiding light. He is also guiding a PhD under a joint PhD scheme. And for that, we would like to thank you, sir, for always being there with us and being just a call away. And that makes us feel really proud looking at your contribution in the research world. It is something that we feel proud to be associated with you. With this small note, sir, would hand over the session to you. Sir, over to you on the topic geotechnics with geosynthetics.
Thank you, Professor Madhuri. This is a great time for us through this international conference. Honorable dignitaries on the dais, distinguished guests, conference delegates, ladies and gentlemen. Very good evening to all of you from Perth, Australia. I am honored to join you all to deliver my keynote talk in this 4th International Conference on Trends and Recent Advances in Civil Engineering, TRACE 2022. My topic of talk is geotechnics with geosynthetics. I have organized my talk first with a brief introduction to geotechnics that deals with soils and rocks and related applications in most areas of our life. I was listening the last session talks, and I can realize that how our Indian governments at national level, state level, are doing very well in the development of infrastructure, and moreover, keeping sustainability in mind. The second part of my talk is going to focus on geosynthetics, because we can use geosynthetics and engineering material for development of sustainable ground infrastructures. As the world is talking these days in this 21st century, and that will continue in years to come. Let us see, first of all, what do we mean by geotechnics? It is the branch of civil engineering concerned with the study and modification of soils and rocks and other related aspects. At any project site, we rarely find most suitable ground because project site is almost fixed. We don't have options at many places to make any change. And whatever soil and rocks are there, we need to construct our structure. And we can see that soil and rock as they are present at the project site may not be suitable. So we need to really do some modification, and that study is within the geotechnics. This branch includes several core subjects, including engineering geology, soil mechanics, rock mechanics, and foundation engineering. Modification of soils and rocks is covered in a specialized subject we call the ground improvement techniques. Many universities are offering a one-semester course. The environmental aspects related to soils and rocks are covered in geoenvironmental engineering. Now, we need to know that we as geotechnical engineers deal with analysis, design, construction, maintenance, and renovation of geotechnical ground structure based on the scientific principles and theories as we learn in geotechnics through several subjects. Now, we all know that we civil engineers work not only for civil engineering projects, we need to do in mining areas, agricultural projects, aquacultural projects, power projects. Civil engineers are everywhere. We can see our ground structures, so many types, but we can categorize all the ground structures into 7 basic types. Foundation is one of them. Slope, embankment, retaining wall, earth dam, and other containment structures, tunnel, pavement. So we may find some structures, but we can easily classify that particular structures in one of these 7 basic types. Foundations can be shallow or deep, but we all know that deep foundation is going to cost a lot. And moreover, in most deep foundation, we are using pile foundation. Pile foundation requires cement, steel, which are manufactured materials. And we all know that manufacturing of materials generate CO2 emission. So carbon footprint increases with manufacturing of materials. In years to come, we have to minimize the use of manufactured materials. It means we should try to depend on shallow foundation. And if you want to go through shallow foundation, as I said in the beginning, that ground may not be suitable, particularly, if it is weak soil foundation. So how to strengthen? That is a big question. We have answers conventional way, but today, that's why I am going to say how geosynthetics are going to help. What you see here, rocket launching arrangement here. And for that also, we need very stable foundations. So you can see here that we need for the proper launch of the rocket in the particular direction, because satellite has to be placed in a particular location. And if foundation is not stable, certainly the mission is going to fail. Now, slope. In case of slope, we can see these days in newspaper headlines what is happening. Heavy rainfall, unexpected rainfall, and landslides, particularly in hilly terrains, and wherever we have slope. And when slope is going to fail, we need to rehabilitate it. We need to stabilize it. Can we do in a conventional way? Answer is there. But if you see that technique might be using construction materials like heavy retaining walls, embankment construction over the soft foundation soil, it is not possible in a convenient way without using some kind of reinforcement. Earth dam. This is the structure, and we all know that we need filters on the downstream side. We need some kind of impervious layer in the upstream side to avoid seepage through the dam embankment. So I am just trying to point out the problems. We have answers to these problems in a conventional way. What you see here, a thick, heavy retaining wall, and this retaining wall needs either cement concrete or brick masonry, stone masonry, huge amount of material. If it is, let us say, 1 kilometer long, how much materials we are going to use? And in most cases, we are dependent on manufactured materials. In tunnel, because tunnel is the future of in future, that in urban areas particularly, we need tunnels. Or in crossing a hill, because if you are not trying to make the tunnel, the length of the railway track or pavements are going to be long. So we can reduce the length of the road or railway track by designing and constructing tunnels, which is going to be costly, but we need to understand that managing the tunnel, particularly in the water environment, is not easy. And how we can do that, I am going to share with you. And finally, you can see payments. Payments include rigid payments, flexible payments, and also railway tracks. We have challenges in construction of payments because that subgrade, if subgrade is not of the proper strength, and also if it is clay ground, then the thickness of sub-base cores or base cores cannot remain intact because of intermixing, particularly during monsoon period under the traffic movement. So life of the payment is going to be lower in terms of, because we can see more ruts if we are not, or some other failures, if we are not going to really properly design and construct our payments. In hilly terrain, we can see the materials, right? The material is, a mix of particles varying from clay size to boulder size, and we can observe what are the problems. And particularly here, you can see this photograph is from the foothills of Himalayas, and particularly when there is rainfall, there is a movement of the materials, failure of the slope, and these materials can easily flow. And when they are going to flow, river starts from hilly terrain, the materials are going to be in the river beds. And we all know that there are different regions. Temperature rise is also one of the causes of sea level rise, because melting is going on. But these materials are also being eroded through the running water, and sea level is going to rise, and that is not desirable. Whenever we see soil, this diagram we teach in our undergraduate classes. First lecture starts with this phase diagram. What we see here, that soil is a natural material that consists of solid particles, mineral particles, and we have voids occupied by air and water. And compared to our other manufactured material, we have variations significantly from location to location, even in the same project. Now, we all are talking about sustainability, as in the previous session you have seen, and today also I can see most talks are going to be related to sustainability. For example, sustainable transportation, sustainable construction materials, sustainable practices in water resource engineering. In all these areas, if you want to do sustainable construction, geosynthetics are going to help a lot, because geotechnics is involved there. Whatever project in civil engineering, mining engineering, agricultural engineering, aquacultural engineering, we have to deal with soils and rocks. We have to deal with ground. Now, root cause of environmental damage is global urbanization, also global industrialization. We all know about that. So, in reality, the sustainable development is the challenge of meeting human needs for natural resources, industrial products, energy, food, transportation, shelter, and effective waste management, while conserving and protecting environmental quality and the natural resource base essential for future development. Geosynthetics are going to help a lot in most areas for achieving sustainable development. And I am going to share some of the developments where we can achieve sustainability. What do we mean by geosynthetics? Geosynthetics is a generic name, family name, which includes a broad range of products. Mostly they are planar products manufactured from polymeric materials. They are manufactured for the use to improve the performance of engineering works involving earth, ground, soil. Now, we have to see that geotechnics with geosynthetics have sustainability consideration benefits. Over the past 40-45 years, the engineers have shown an increasing interest in geosynthetics and their field applications, mainly because the use of geosynthetic offers technically efficient, cost-effective, environmentally friendly, and or energy efficient sustainable solutions to many field problems in the areas of civil, mining, agricultural, aquacultural, and power engineering. I have written an editorial one can download by going through this link, and if you do Google search, you can find more details can be seen there. Now, we need to know that geosynthetics have many favorable basic characteristics: non-porogenous, highly resistant to biological and chemical degradation, long-term durability under soil cover, high flexibility, minimum volume, lightness, ease of storing and transportation, simplicity of installation, speeding the construction process, making economical and environment-friendly solution. So you can see that geosynthetics have many advantages, and we can play magic in our construction. And if we want to achieve some better aesthetic look, that is also possible. Now, importance of function, we need to understand that whenever we select a particular geosynthetic, the selection for any field application is highly governed by the function to be performed by the geosynthetic in that specific application. What are the basic functions? Reinforcement. Wherever soil is weak, we need to strengthen the ground. We can select geosynthetic for strengthening our soil, for increased load carrying capacity, for reduced settlement. Separation we need, as I mentioned in the payments, because subgrade and sub-base material or base material, they need to get separated. Filtration, in many applications, we need filters, drains, fluid barrier, protection. All functions can be achieved by selecting a proper geosynthetics. Now, basic types of geosynthetics, you can see here list geotextiles, geogrids, geonets, geomembranes, geoshells, geofoams, geocomposites. Now, I'm going to share with you some photographic views of sample without much discussion. Whatever you see here, typical oven geotextile, which are commonly used as a reinforcement. How to reinforce the ground? Yes, we can use oven geotextile. We have non-oven geotextiles. Generally, they are used as filters or in-plane drainage medium. We have knitted geotextiles, stitched geotextiles. Now, geogrids, many types of geogrids. Here, whatever you see, extruded uniaxial geogrid. This product is having tensile strength in one direction, but biaxial geogrid, we can see they have tensile strength in both directions, suppose in the plane in X and Y direction. We have nowadays better geogrid, triaxial geogrid, and you can see that three directions are there in the same plane, right? And we can have better isotropy in terms of the strength. We have bonded geogrids in addition to extruded geogrids. You know that we have been talking about startups and unicorn. Some of us can start our own industry business to manufacture geosynthetics. So we can see the variation in products because companies are trying to produce more and more products, keeping in mind that they should not copy, and moreover to meet the that particular field requirements. We have oven geogrids. Next type is geonet. Geonet is basically, you can see their channels. So this is used as a drainage medium with a combination of basically geotextiles. Geomembranes. Most geosynthetics, as you have seen, they are highly permeable. Water can flow from one side to the other. Gas can pass through. But geomembranes are almost impermeable membrane. Wherever we need liner, let us say in ponds, in reservoir or landfills, we can use geomembranes. Geoshell. At many project sites, we may not have proper ground, means stable ground. Then we need to create a stable platform. How we can do that? We can use geoshell. This is just a small sample, but you can see in line diagram that generally this geoshell is supplied in the form of rolls, collapsed form, but at the project site we can expand it. And one of the cells you have seen in the photographic. So we have so many cells, and these cells are filled with granular materials to create a firm base over the, let us say, weak foundation soil or even sloping ground. We can have a site assembled geoshell because in this case we can manage, more depth using the biaxial geogrids. Now, geofoam is a lightweight product in slab or block form with a high wire content and has applications primarily as lightweight fields, thermal insulators, and drainage channels. Just a small piece of geofoam. So if we need lightweight field, yeah, we can recommend this product over the weak foundation soil. We can create our own geosynthetics in the form of geocomposites. You can see here reinforced drainage separator, biaxial geogrid combined with a non-woven geotextile. Then this is prefabricated vertical drain, geonet, which is the core sandwich between two non-woven geotextile, generally needle punch non-woven geotextile. So this product is used as a drainage medium. And we have so many drainage geocomposites. Companies are creating their own products with their own patents. Now we have geosynthetic clay liner. Here we have bentonite powder, a layer of bentonite powder sandwiched between geotextile layers. This is used as a liner in, let us say, landfill and other places wherever we need, liner system, because I will show you some photographic view of liner installation. In addition to the basic types of geosynthetics, as I mentioned, geotextile, geogrids, geomembranes, and others, we have some other products. And we might be giving some names like geomat, geomeshes. Now, this is geopipe, three-dimensional product. And if you closely observe, you can see that there are no holes in some portion, but in most portion, in the top, in the side, there are holes. So water can easily enter in the pipe, and if it is installed at some gradient, that can flow. And we are using this geopipe in many areas, and some of them you will be able to see in photographic views. We have geotube. Now, most geosynthetic products are manufactured from synthetic polymers like polyester, polyethylene, polyamide, polyvinyl chloride, but we have natural products as well. So in future, we have to focus on how we can go for manufacturing geosynthetics more with natural polymers, let us say. And in many applications, we need use of geosynthetics for limited time, particularly in erosion control or even in some payments as well. So geonatural, so here you can see geocoir, geojute, non-woven geojute. Now coming to geosynthetics supply, they are generally supplied in the form of rolls. You can see the photographic views here. And the functions, as I said, you can see how we can install in a slope. There is only one layer, but we can have more than one layer to achieve the reinforcement function. Here we are trying to explain how we can get benefit of separation function, because if we are not separating, you can see there is loss of granular material, particularly in road pavements, railway tracks. Now here you can notice that water can flow, but soil particles can be avoided, right? The flow can be minimized, and that flow migration, if takes place, that should be for limited time. So filtration function, we can see here drainage function. Now fluid barrier function in liquid waste or any pond or reservoir. Now we are using geosynthetic as a protection layer also, protecting geomembrane or any other structure. So you can see that there is a dashed line, that is geotextile, that is protecting the geomembrane, because geomembrane, if we are installing in any pond, it can puncture. So we need protection. Now, we know that any engineering material has their properties. And here just I am giving the group names like geosynthetics have physical property. There are several types. We have standards for all properties, mechanical properties, hydraulic properties. Whenever we are using, we need to do some testing, and we need to determine the design properties, and we have a standards available. Now, major application, just here I am giving you a list, and then I will show you the photographic views because we have limited time for this talk. So first, let me give you the list. Geosynthetics can be used in earth retaining structure, embankments, foundation, unpaved roads, paved roads, railway tracks, slopes, landfills, earth dams, containment ponds, reservoirs, filters, drains, tunnels and underground structure, mining projects, agricultural projects, in all areas, the way I mentioned. And for what? For cost effectiveness, for sustainability, for environment friendly solutions, we are using geosynthetics in our all areas of geotechnics. Now, aim of using geosynthetics is to do the job better in a cost effective, environment friendly and sustainable manner. Geosynthetics can have a lifespan of about 120 years. So there is no issue because most, we all know that we design our structure, let us say for a maximum period of 100 years. So they are going to play their role. Now, in this diagram, you can see as temperature increases, particularly for synthetic polymers, we can see that there is no problem up to, let us say, 200 degrees Celsius. But beyond 200, they are going to be, going to lose their weight. It means they will burn and we will have ash. Fortunately, in our civil engineering or any ground engineering applications, our temperature is not going to be more than, let us say, 150 to 200 degrees Celsius. So that is not an issue. And this is the key mantra: to install the correct geosynthetic in the correct location without having its properties impairing during the construction stage of the project. Because if we are not designing the proper geosynthetic, we are not selecting a proper geosynthetic, the project is not going to be successful. So just let us see some of the diagram. This is the conventional retaining wall. Nowadays, no, we are not going to have this, heavy concrete wall or brick masonry wall. So you can see construction of the retaining wall using geosynthetics here. That is biaxial geogrid. And where is the wall? Wall has become very thin, just modular concrete blocks as a facing element. And this is the case study from the Mumbai-Pune highway. And you can see here geopipe has also been used, geogrid has been used. So complete details can be found in the books. In embankments, we have at the base layer we can place if the foundation is weak. If there is a locally weak zone or sinkhole, again, more than one layer can be placed. We can have, drainage material sandwiched between two geotextile over the soft foundation soil. We can go for vertical drains like PVD because that helps speeding the consolidation process. In case of unpaved road, because in mining areas we have haul roads, forest road, many places we need unpaved roads. There is no hard surfacing, but still we need geosynthetic as a separator so that we can maintain the granular layer thickness. This is one of the case study, and you can see that without geotextile, the large ruts, but with geotextile, they had maintained the rut up to 100 millimeter. And they did for a 20 kilometer long, and they created their own geotextile from the waste synthetic fibers by needle punching. So some of us, like students who are young, they can think about their own startup in this area because there are many companies are there, but still there is a scope. Every day we can see some new type of geosynthetic material is being presented in the market. Now in paved roads, we also need geosynthetic at 2 layers. We know all that in paved road, we have surface course, base course, sub-base course, subgrade, and this is runway. Okay, so in runway also we have similar layers as we have in flexible pavements. Now advantage you can see in this diagram that the thickness can be maintained. Otherwise, there is loss of granular material. Now, this is the case study from National Highway in Varanasi. When I was there, I was in bold, and they had used, because CBR value of the subgrade was 5, and they had used needle punch non-woven geotextile. You can see the photographic view, the installation of non-woven geotextile as a separator, and then over that you can see the granular base course, then sub-base course, base course, and finally the surface course. In 2018, I had visited Bhavnagar area of the Gujarat, and you can see the subgrade was very weak. They have used the geogrid to strengthen the pavement base. Now there is one more location, because old pavement, it may be concrete pavements or bituminous pavement, how to renovate it. So we can use a paving fabric with some tack coat, right? And that tack coat, there is a proper design, but that is another location where we are using. You can see we have bitumen pre-coated fabric for localized repair these days. And studies have indicated that if we are not providing proper tack coat, failure is going to be there, right? So most failures have been because of insufficient tack coat. So if we are taking decision for a new overlay, we can install paving fabric, but proper selection of tack coat amount is required. These days in railway tracks, you might be observing here and there, if you are nearby, that below the ballast, we are going to place a separator layer of needle punch non-woven geotextile and geogrid. So a geocomposite, you can say, and that provides several benefits. Otherwise, you can see what happens in the railway track. There is mud pumping, so whole ballast can get contaminated, and that is undesirable. In foundation, we can have 1 layer or 2 layers. Then if you see breeze abatement, we can also install geogrid layers to increase the load carrying capacity, reduce the settlement. During 2007 and 2008, I have developed a wraparound reinforcement technique, because when land width is limited, and particularly if you want to achieve more benefits from the same amount of reinforcement, this technique is going to be useful. And my research team has done a lot of research. You can see just one of the laboratory arrangement for doing the test. And we published a lot, and we have shown that reinforced soil with wraparound ends is going to provide higher ultimate bearing capacity. And if we are going to have fully wrapped, then this is the diagram curve, and you can see for any settlement, we are getting higher applied pressure. So wraparound reinforcement technique is going to be very useful even in road payments. We need to know how to do it, and I have explained in our research paper and also in my books. There is an excellent case study in Canada, how they avoided deep foundation. In the beginning, I said we need to avoid deep foundation, and this is 2015. They reported a case study. You can see the photographic view, geogrid rolls, and they created in harbor area a shallow foundation. Otherwise, without geogrid, it was not possible. Another option was deep foundation, that was costing a lot and not sustainable as well. In slopes, you can see these days, as I mentioned, if there is a slow failure, how to stabilize that failed material. This is the best case study. We can have some long length reinforcement, short reinforcement, and then we can do stabilization in a cost effective and sustainable way. Otherwise, in conventional way, very difficult to manage that failed soil slope. We can have drainage system, as you see in this diagram, that there is a geopipe, and we can have a wrap of non-woven geotextile. Behind the retaining wall, you can see a geocomposite, geomembrane, geonet, and geotextile. So concrete wall is not in contact with water, suppose in basement also, a retaining wall. And then in nowadays, we need that sub drainage system in our highway pavements, in railway tracks. Very easy, narrow trench and geocomposites are there. One can install, because water should not stand in the pavement layers. Okay, and we have coastal protection. This is the conventional way of construction, that we have graded soil filter. Very difficult to maintain the continuity in the filter. But nowadays we have geotextile filter before the placement of the rebatement or primary armor, right? So I am sharing, nowadays very common, we should use geonaturals for vegetation growth on new embankment or any sloping face. How vegetation can grow easily, because soil and seeds can keep moving, manure can keep moving, and we can do better with geonaturals. Coastal protection, if you have visited coastal area these days, we are using geotubes, right? And we can create a nourished beach profile with the placement of geotubes. And in tunnels, how to manage, in modern tunnels, you can see geotextile, geomembrane, geotextile, they are being used. We can't see while driving through the tunnel, but geosynthetics are helping us in a cost-effective way to manage the water, means drainage management, to keep the tunnel dry, basically, you can say, and avoiding pressure over the tunnel lining. So you can see a photographic view here. We have done research in buried conduits, as you can see. What we did, that we measured the really pressure, but what happens that in some of the conduits, buried conduits, we might not have a conduit of required thickness. So we can reduce the load by placing some geosynthetic over that. And we did a lot of research in that. We published also in dams. In the beginning, I mentioned that this is now a common practice. Many old dams are being rehabilitated. So let us say filter making is through the geotextile. We can have geomembrane on the upstream face. We can have geomembrane in the reservoir if we have to avoid infiltration of water. This is one of the local dam here in Perth. You can see a view. Revetments are there, but behind that there is some type of geomembrane. And this is engineered landfill, certainly not. But in engineered landfill, if you closely observe, we need compacted clay liner. Now we need GCL, geomembrane, we have drainage blanket. So we need geosynthetics of different types. After the life of the landfill, let us say 8 to 10 years, we need to cover it. In cover also, we need geosynthetics of different types. So we, as practicing engineers, what I am sharing with you, you can see GCL installation here in one of the engineered landfill in the Perth, and geomembrane installation in the pond. This is just line sketch to show in canal. Here you can't see, but you can see some pipe, and there is lining or geomembrane as well. So most details are given in my textbooks, as you can see here, 2 textbooks. The most recent one is 2016. Then we have I have tried to focus on reference books, and this is the most recent 2022. there are chapters for specific applications. So practicing engineers, researchers, students, if they are working on any particular application, they can refresh the fundamentals and advanced understanding by going through those chapters. We have research journals because we practicing engineers need to be in regular touch with this subject, because subject is still growing, developing. It's not stabilized. So that's why I say that those who are young, they can start their own business, their own industries in this area. Although there are hundreds companies who are manufacturing, supplying. So we have, and this is the research journal where I am not only geosynthetics, but also ground engineering. And whatever in the past I have done, that has been appreciated in 2018 by the most prestigious award. And thank you all for being with me. I think I might have taken, it appears to me, how much? I think some couple of minutes more. If time permits, I am happy to answer questions, but we all can keep in touch. You can see my contacts on the screen, and we have professional WhatsApp group. Those who are interested, they can send me WhatsApp message. Thank you.
Thank you so much, sir. In fact, I would say that, so much of picture supported presentation, it makes the things, it makes easier for the audience to understand. And all the relevant advancements in the area of and geotextiles that you have pointed out, and mostly around the technical engineering aspect. And the last one was very, very relevant for, I'll take away for the audience, particularly students of civil engineering or the master's degree, or whoever is pursuing master's degree or research. Very well written and very relevant text. So, and it was indeed a very informative lecture, and I'm sure that the participants must be having a great takeaway from this session. So we would definitely want you to give us some more detailed session in the times to come, and we'll get connected to you to see how we can do a dedicated webinar by you. And in case you are visiting India in near future, we would definitely like to host you at Amity University, and so that we can plan a particular research-based session that you do for mainly BSD scholars, and how to publish paper and things like that. So thank you once again, sir, for being there always with us, and just a phone call away, not even call, it's, I would say, in this era, sir has supported us through the WhatsApp message as well. You are so very accessible, and every time we have any queries or anything related to civil engineering, we can reach out to you. So thank you once again, and we are really lucky to and fortunate to be associated with you. So would just like to let you know, we have in the panel now our head of the department, Professor Dr. R.K. Tomar sir, and our senior colleague, Dr. Priyanka Singh. She has joined from Malaysia. She is there on the scholarship. Dr. Priyanka Singh.
Yeah,
Hello.
good evening, sir.
Good evening.
So your presentation was really wonderful, sir, and we really get this kind of opportunity to listen to the words of a great knowledgeable speaker, and we are really having gratitude and the time that you have spent for our international conference. So we are looking forward to have a long-lasting relationship with you, sir. And thanks once again for presenting such a wonderful topic. And that is what we can say, it is in demand in the field of civil engineering. So thank you so much, sir. And we welcome you for our next conference that we would be organizing in 2024. So invitation is there, and I hope definitely you would be accepting it. Thank you so much, sir.
Yeah, thank you. I wish a successful completion of all the sessions. And I think tomorrow, it is going to be completed. So really, thank you for this great opportunity. We are already in good touch, and TRACE 2022 is the 4th international conference. So this is, I will say that it is going to continue in years to come, wherever we are. And in 2024, as you said, really, I would like to be in face-to-face mode, and in future, because you know that geosynthetic engineering has become a full 1-semester course. But what I have tried, as you nicely summarized, that many delegates here, or students, researcher, practicing engineers, they can get an overview idea that there is engineering involved, and we can achieve really sustainability in all areas beyond civil engineering. Thank you.
Thank you so much, sir, and
Yeah,
namaskar
thank you,
from
sir.
Thank
India.
you. Bye.
Thank you.
Namaste.
Yeah.
Namaste.
Yeah.
Namaste.
Thank you, sir.
So for the audience announcement that the next keynote lecture that is coming up is by Professor Krishna R. Reddy, Professor and Director of Geotechnical and Geoenvironmental Engineering Laboratory, which will be starting at 6:30. And he is from University of Illinois, Chicago, USA. Followed by that, we will be having a keynote lecture by Professor Yusuf Mehta, who is Professor and Director of Creates Lab, Henry M. Rowan College of Engineering, Rowan University, USA. And post that, we are going to be having a panel discussion, listening to the panelists from Penn State University, RD University, and Loborg University, UK. So stay in tuned, and we are returning back in less than 20 minutes for the next keynote lecture. Thank you, Dr. Priyanka Singh, for taking it over, and request you to take it over from here.
Definitely, ma'am. Definitely.
Yeah.
Definitely.
Okay. So just for your information, I would be traveling in for next 40-45 minutes before I leave. So request you to kindly be tuned in. The moment my video goes on, you can actually, you can rest out. I know it's too late there.
Yeah, I'll manage, ma'am. You
can
can,
sit.
you can manage your stuff. I'll be here. And
Sure.
don't worry.
Yeah.
Okay.
Dr. Priyanka, just one note. I mean, I'm not sure how the road condition is. So maybe beyond 7:30 also, just stay in there till the time my video is on, right?
Yeah, I'll be there. I'll be there.
Thank you.
Please
Thank you
don't
so
worry.
much. Yeah. Thank you.
Thank you, ma'am. Yeah. Yeah, I'm Dr. Priyanka Singh from Department of Civil Engineering, and a very good morning to you. I think it is 8 o'clock there in US, and
Yes.
from where I have joined Malaysia, it is 9 o'clock night, and in India it would be near about 6:30 or somewhat. So I'll just invite our HOD and our Deputy Director, Dr. Madhuri Kumari, and then we will start the session. I think they have joined. They have already joined. So a very warm welcome, sir. So with the blessings of Honorable Founder President, sir, and Honorable Chancellor, sir, and valuable guidance from Vice Chancellor, ma'am, Department of Civil Engineering, Amity University, Uttar Pradesh has organized a highly informative and enlightening session based on the theme Sustainable and Resilient Civil Infrastructure, Future Reimagined, and our keynote speaker for this session is Dr. Krishna R. Reddy. It is a great pleasure to welcome such a noted personality. This indeed is a matter of pride and great privilege to welcome our keynote speaker, Dr. Krishna Reddy, to our 4th International Conference, Trends and Recent Advances in Civil Engineering. Dr. Krishna R. Reddy is university scholar, distinguished researcher, and professor of civil and environmental engineering, Director of Sustainable Engineering Research Laboratory, SERL, and also the Director of Geotechnical and Geoenvironmental Engineering Laboratory, GAGEL, at the University of Illinois at Chicago, UIC, USA. Dr. Reddy has over 28 years of research, teaching, and consulting experience within the broad fields of civil, geotechnical, materials, environmental, sustainable, and resilient engineering. His research expertise includes environmental remediation of soils, sediments, groundwater, and stormwater, soil and hazardous waste management, and landfilling engineering, engineering application of waste, recycled materials, life cycle assessment, and sustainable resilient engineering, and geotechnical engineering. His research is funded by federal, state, and local government agencies and industries. Dr. Reddy is the author of 4 major books: Sustainable Engineering Drivers, Metrics, Tools, and Application. Second one, Geo-Environmental Engineering, Site Remediation, Waste Containment, and Emerging Waste Management Technologies. Third one, electrochemical remediation technologies for polluted soils, sediments, and groundwater. And the fourth one, sustainable remediation of contaminated sites. He is also author of 282 journal papers with H index of 70, proud to say, 21 edited books, conference proceedings, 22 book chapters, and 224 full conference papers. Dr. Reddy has given over 200 invited presentations in the USA and 22 other countries. Dr. Reddy has received several awards for excellence in research and teaching, including the ASCE Wesley W. Horner Award, ASTM Hogan-Togler Award, UIC Distinguished Researcher Award, University of Illinois Scholar Award, and University of Illinois Award for Excellence in Teaching. He is a fellow of the American Society of Civil Engineers, FASCE, a diplomat of Geotechnical Engineering, DGE, and a board certified environmental engineer, BCEE. He is also a registered professional civil engineer, PE, and an Envision Sustainability Professional, ENVSP. So, sir, I welcome you to this fourth international conference that we are conducting at Amity University Noida campus. And you are most welcome with the honor to enlighten our participants, delegates, faculty, and students with your precious words. Over to you, sir.
Yeah, thank you very much, Dr. Priyanka Singh. Can you hear me well?
Yeah, I can hear you, sir.
Okay, let me see if I can share the screen. Let me know if you can see the screen.
Yeah, your screen is visible.
It's showing double. Now is it good?
It is not in the slideshow mode, sir. Yeah, now it's perfectly all right. Yeah.
It's in the slideshow mode. So let me see.
Yeah.
Does it advance?
Exactly. Yeah.
Okay. So thank you again, for that long introduction. I should make it very brief. But I'm very happy to be here and presenting on a topic that, consistent with the theme of the conference, trends and recent advances. And I chose this geo-environmental topic, polluted sites, which is becoming an extremely important issue here in the US and in India and everywhere in the world. So before I get started, I really want to thank Dr. Madhuri Kumari for her invitation and all the support communication. And also I want to thank Dr. R.K. Tomer, department head, for supporting activities like this conference and inviting all the good keynote speakers. And yeah, I want to really congratulate Amity University for taking up this conference series on a very, very important topic of addressing latest and the the most important issues in civil engineering. I had a memorable experience, participating in the last conference. And know it was during the peak of the pandemic, but at least that I have kept everyone busy and distracted from what is going on around us. That was really nice, and I wish this conference to continue more into the future. And I was humbled to receive honorary professorship during that time, during that conference. I really, thank the Amity University, all who are responsible for this one. I hope I want to visit your university one of these days. And I want to, thank conference organizing committee and all the attendees who are attending this conference and benefiting from all the latest advancements in civil engineering. So everyone, I want to entice you with this picture to visit Chicago. Anytime you come to US, I will be your host. So it's a great place to visit. So anybody in the audience, all the Amity staff, faculty, administrators, if you ever come to US, please visit me. It's a beautiful place. As pointed out in my bio, I am in charge of these two labs, Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab. I do a lot of work on remediation of contaminated sites. I work on waste management and landfill engineering. And I work on this broad theme of life cycle assessment, sustainable and resilient engineering, which is very, very important in civil infrastructure in general, any engineering systems. And my core background is geotechnical engineering, and I have a civil engineering undergraduate degree. So if you want to know more about my research projects, you can go to this website, you can find it. And I always show this picture because without, all these students and scholars' contributions, I would not have contributed to what I did so far. So I always thank these students and visiting scholars for working hard in my lab. So coming to the presentation, I will give you a brief overview to the contaminated sites problem, current remediation approach, and what are the problems with the current remediation approach, and then what is evolving, what is trending, what is new. So this is where green and sustainable remediation comes into picture. And I will give you a case study to understand how this kind of concept can be incorporated in the future. So contaminated sites, there are a lot of them. You cannot see, contamination of the soils and groundwater because this is all hidden underground. You see, if a polluted lake, you can see it. Air pollution, you can see it. But this is like a hidden problem, and there are many contaminated sites and posing a lot of problems all over the world. So and it is receiving a lot of attention these days all over the world. And what are the sources of contamination of soil and groundwater? There are many sources. I listed many of them here. If you ask me one major source, that would be the land disposal of solid and liquid waste. So people, this indiscriminately, even the industry, chemical industry and all the industry, they just dispose of the waste, in their backyards or, in open yards, and then that causes a lot of problems. There are a lot of sites in the US that have been identified as dangerous and needs to be cleaned up. And we are doing that one in the US. We have regulations, we have strict enforcement, and we are doing a lot of things to clean up the sites. But there are such sites in the EU, European Union, and other developing countries, Brazil, China, and India. And all the countries are now paying attention that, hey, soil pollution is not good because, if soil is polluted, anything you grow on the soil is going to be contaminated. The food that you eat, the fruits, vegetables, and everything are going to be contaminated. So people have realized that, you cannot ignore the soil and groundwater contamination, and people are doing a lot of work. I just had a quick internet search on contaminated site situation in India, and I'm glad to see that it is receiving attention. And I'm surprised that they identified already, 280 sites that are posing a problem that needs to be remediated. I think these are known, but I know, there could be many more sites. And other thing that I noticed is there is a limited experience in the country on remediation of contaminated sites. So when I saw that one, I see all these researchers and students, youngsters. This is an area that needs to be pursued because this is an important issue, and we need manpower to take care of these projects and address it. So if you have a contaminated site, there is a systematic procedure that we follow in the US. It's called risk-based remediation approach. So if you have a contaminated site, you do the site characterization, then you do the risk assessment, and then what do you do to reduce the risk, and what are the technologies, and then you pick the technology and implement it, and then monitor it, and then it becomes a useful site. So we follow this logical procedure, and almost all over the world, people follow this approach. There are different remediation technologies that have been developed, and one should be aware of what are the technologies that are out there. For example, monitor natural attenuation. There are containment technologies. There's a remediation technologies. So there are different technologies to do that. Specifically dealing with soil, if you want to remediate in situ, you have all these different contaminated sites, different remediation technologies. If you want to excavate the soil and clean it, these are all the different technologies. I'm still showing you a source in the bottom, so you can find more information about each of these technologies if you're interested. And then groundwater remediation technologies. So you can see these the technologies are there, and there is more research being done to improve these technologies or develop new technologies. So this is the reference. If anybody is interested in knowing about these technologies, I strongly suggest you to get hold of this book and learn these technologies. So what is the problem with the current practice? We select the remediation technology to reduce the concentrations to risk-based levels. That's then you're not having any issues with the contamination at the site, which is very, very important. That's the basic problem, right? I mean, if you have a contamination, it is posing problem to human health and the surrounding ecology. So you want to avoid that problem. That's kind of a most important thing. But and also we want to do that one with the technology that is easy to implement, cost less, and takes less time. However, we don't consider the broader secondary negative impacts. So what is the amount of energy that is needed for the technology implementation, and what kind of air emissions that we are going to have, secondary waste that is going to be generated, what kind of natural resources that we are going to use, right? The focus is more on reducing the contaminant concentrations and looking at these other things, which is fine, but in the context of what is going on around with the sustainability and climate change, it is important to consider these additional factors, right? So what is the net environmental benefit of cleaning up the site? If you are cleaning up the site and causing more environmental damage in terms of air emissions or secondary water pollution, that's not good. So you are asking this question about what is the net environmental benefit? And more importantly, what is the societal benefit? What are the economic consequences of this one? So those are like a sustainability triple bottom lines. So to address all these issues of environmental, economic, and social issues, this concept of green and sustainable remediation has emerged. It's called GSR. And in site remediation field, now people are thinking about doing the things like what we were doing before, but at the same time, as I mentioned here, the definition, you're going to mitigate the contamination risk to receptors, but we should do that one while balancing the community goals, economic impacts, and environmental effects. So this balancing. We are good at engineers, environmental, civil. People are very good in doing the technical stuff, but how do we do that technical stuff while balancing these community goals, economic impacts, and environmental impacts? That's the one which is not conventionally taught in curriculum. So now it is becoming very important to consider these things in any engineering designs that we make. Now, functional definition is this. So you want to reduce the contaminant concentrations to risk-based levels to protect public health and the environment. That's the primary goal. That's perfect. But what we are saying is, hey, while doing that one, you consider this triple bottom line. So environmental, social, and economic. So this is kind of a secondary goal. But the overall approach should be to balance both of them, to achieve both of them, primary goal as well as secondary goal. So that's how do you do that one, okay? Some people get carried away. Oh, I don't know about this economic and social impacts, and so how do we do it? So you need a roadmap. So this is kind of a roadmap a methodology. So you do the site characterization, and then you do the risk assessment and remedial goals, just like what we have been doing. And then you identify the potential remediation technologies. And then right now, instead of selecting right away the proper technology, we need to do this sustainability assessment. This is the most important part, in this one. So when you identify different potential technologies that can do the job, right, reduce the risk, but which one is more sustainable? So that involves using the sustainability assessment tools. So quantifying the sustainability of these different technologies. And then if you can do that one, and then rationally, you will be able to select the technology that is more sustainable. So now the question comes up, what are the tools that are available to quantify the sustainability? There are different tools, sometimes you don't have to have a tool and complicated, methodology. You can follow best management approaches. There could be qualitative assessment tools, semi-quantitative assessment tools, or quantitative assessment tools. But also, if you want to go to the other extreme, you want to do detailed sustainability assessment, then you do the life cycle sustainability assessment, where we consider the life cycle of the project, and then we consider the triple bottom line aspects. So this is what I like it. I like doing the life cycle sustainability assessment. This is kind of a holistic, comprehensive approach that can be applied in general. So in briefly, how do you do this one? Basically, we consider the triple bottom line: environmental, economic, and social. And you need to come up with these indicators that represent the environmental impacts. And you need to consider the economic indicators that, that reflect the direct costs and benefits and indirect costs and benefits. And socially, how, the project outcomes are going to be impacting individual in that community or overall community, and the overall community's economic situation, how overall community's environmental situation is going to be, impacted. So, but all these indicators should be selected very carefully because we want to quantify them. So you need to have a metrics for each of these indicators. You cannot, pick one that cannot be quantified. So you need to have tools to calculate those indicators. So this is where, a lot of interesting things are happening. I want everyone to pay attention to quantifying the sustainability. Just don't talk about, how important is the sustainability. But if you can quantify the sustainability in the process, you can really do a lot of different things, make the practical difference. So what we do is here, so we have in remediation field, we have all these different steps, right? In the life cycle stages: raw material acquisition, manufacturing, transportation, implementation, remediation, and at the end, what you want to do it. So at each life cycle stage, we want to consider the triple bottom line, consider the environmental impacts, economic impacts, and social impacts. So when I consider each stage and consider all these environmental indicators, economic indicators, social indicators, I got like a big spreadsheet. And having that big spreadsheet with a lot of these indicators, a lot of these numbers, and making the decision is a nightmare. So is there a way that we can combine all these indicators, all these different values into a sustainability index, right? So, and if you have that overall sustainability index, that we can use that one to compare different alternatives that we have. So that's where we develop these frameworks or methodologies. How do we combine all these different parameters and their values and come up with a sustainability index? So this is basically multi-criteria decision analysis. So we have environmental indicators, economic indicators, social indicators, and you can apply weighing factors depending upon the importance of those. And then you have a criteria level and requirement level. So at each of those levels, you can apply weighing factors if needed. Otherwise, you can assume equal importance. And then following this methodology, you can apply weighing factors based on analytical hierarchy process. And you have a value functions that normalizes all the values to 0 to 1. And basically, you're applying this multi-criteria decision analysis, and you're calculating the sustainability index. Unfortunately, I don't have time to go through this one, but I highly recommend you to look at my publications that will detail. And you can contact me, if you need any help in calculating these sustainability index. So quickly, what I want to show you is how do I apply this one? How do I apply this, right? So let's say I'm going to give you an example. This is a contaminated site which is close to the Chicago area. It's in the state of Indiana. It's a 65-acre site that has all these industrial, commercial, and residential properties. If you look at this one, this is the map on the right side. That's the industrial, commercial area. I mean, that could be the situation in India too. India is has all the built-up areas, and that could be area that's contaminated. So looking closely, at this side, you have a lot of these industries, businesses, and then residential areas. And what happened is they were, dumping a lot of stuff into the ground, and the contamination went into the ground and, caused this plume. This shaded area here that shows the extent of contamination. Once contamination goes into the groundwater, it's not going to stay stable there. It's going to move with the flowing water. And they found out that groundwater is contaminated with all these toxic carcinogenic chemicals. So in high concentrations, that's why you need a remediation. Then question is, what is the evaluation criteria? What factors that we consider, and what are the technologies that are there to do the job? And then we kind of, screen out the technologies. Monitor natural attenuation is found to be not applicable, but we have a pump and treat, in-situ air sparging, bioremediation, and in-situ chemical oxidation. These are the technologies that could be applied for this site. And then this is where you do this sustainability assessment. So you can have different tools that you can use, or do the general life cycle assessment. So for example, for this case, I used the tool and I calculated the environmental metrics for pump and treat. So total energy used and greenhouse gases, water consumption, accidental risk fatality, for this technology. And then for second technology is in-situ chemical oxidation. Again, I use the tool and calculate these metrics and find out, all these numbers. And then this is the other third technology, air sparging and bioremediation combination. And then I find out, all these metrics. So total energy, right? I mean, you want to use the technology that uses less energy. You want to have a less greenhouse gas emissions because that's the climate change issue. And water consumption, you want to have the technology that uses less and less accidental risk. So it's extremely important to consider these factors because all these three technologies can reduce the risk, okay, which is the primary goal. But the secondary goal of reducing this, environmental impact, that's important. So here is the comparison of those technologies. As you see it, I have these three technologies: in-situ air sparging, in-situ chemical oxidation, pump and treat. Look at that. Pump and treat is the worst scenario to use. Total energy is very high compared to the other technologies. The other technologies numbers don't even show up, even though I plotted. So clearly, pump and treat is not the best way to use it. And unfortunately, a lot of people think of that as the first option. Oh yeah, groundwater is contaminated. Let's pump, and treat it. But that doesn't work. Also, it requires a long-term operations. So this is the problem. Then cost, right? And cost, direct costs are easy to calculate, and they can also calculate the social cost of carbon, social cost of NOx. So you can calculate the monetized environmental costs, and then you come up with the total cost. And then you will see, all these numbers. And then social sustainability. This is the hardest part. And quantifying the social sustainability is a very, very challenging aspect. And I developed a rating tool called Social Sustainability Evaluation Matrix, SSEM. that is a spreadsheet tool. If you are interested, you can look at on my website. You can download it free. And initially I developed this one for environmental remediation, but now I apply the same thing with the modified indicators for any project that I work on. It could be a design of a bridge or design of a highway. So basically there are a lot of different social aspects and community aspects, economic aspects, environmental aspects, and then we generally do the survey. That would be the right approach. Consider all the stakeholders and then do the survey, get their response, and using the scale, 0, 1, 2, or -1, -2, and then if you aggregate all the results, then you get this grand score, and you can plot this also. So the more positive, better it is. More negative means that's really bad. So based on these scores, you can see, no remedy is always, very negative. In situ chemical oxidation is more positive. Next is air sponging. Next is pump and treat. From the social perspective, how people perceive, how people, get affected. And then we can do this multi-criteria addition analysis. We have environmental and economic and social indicators. These are all the different indicators that you've shown. You have those values calculated by different tools. And then what we do is we normalize those things, because these are different numbers in different units. So we use the value function definition, normalize this one, and then we can apply weighing factors for each of those things. And then we apply this requirement criteria. Again, we can apply the weighing factors for that. And then overall, what is the sustainability index? So I can calculate the environmental aspect, economic aspect, and social aspect, and add them up together. Then I get this overall social sustainability index, overall sustainability index. You can see the higher the better. So considering all the factors here, ISCO, in situ chemical oxidation, comes out to be 0.83, and see, that's the better, compared to pump and treat is 0.11, air sponging, soil bioremediation is 0.51. So this is the way that we can quantify the sustainability and select the technology out of the technology that are practical to be applied. So as I said, sustainable remediation is a new concept, and it is emerging, and we should all embrace this one. We realize this one after doing several projects in the US, but in India, projects are at the initial stages. So you want to do the right things right from the beginning. So there are many benefits of doing the sustainable remediation. And normal misconception is, hey, if I go for sustainable remediation, I may be thinking about spending more money. But in fact, it is contrary. It reduces the overall cost of the project, which is the main criteria for all the stakeholders. And there are, I know it's easy to say than doing it, but there are several practical challenges doing it. I know it is important to do it, but unfortunately, there is no requirement of using the remediation that is green and sustainable. Most of the regulations require you to reduce the risk. That's the bottom line. But hey, do it in a green and sustainable manner. If you have that mandate, then everybody will do it. So, but also some education is important, and all the attendees or conferences like this will help people to be aware of these things and pursue it. So I highly recommend you to look at these other resources if you are interested in working in this area. And of course, you can contact me through email, connect me through social media, and I will highly recommend you to look at my websites for additional information. I want to thank you, and again, I want to thank all the conference organizers for giving me this opportunity, and wish the conference to be very successful today and tomorrow. Thank you very much, Dr. Priyanka. Back to you. Now you're
sorry, sir, I was muted. Yeah. So thank you so much, sir, for your wonderful and informative session. Please accept my deepest thanks that you found time out of your busy schedule and which demonstrated your unwavering commitment to our conference. We would definitely be benefited from the breadth of your knowledge and depth of expertise. Thank you so much, sir. And we look forward to have you again in our next conference. That would be in year 2024. And we really get this kind of opportunity to listen to the words of a great, knowledgeable speaker. So we would like to express our deepest gratitude for your presence to our fourth edition of International Conference on Trends and Recent Advances in Civil Engineering, TRIS 2022. So thank you so much, sir. And
Yeah, thank you
we
so much.
hope that definitely we will be fortunate enough to hear your presentation in 2024 also.
Thank you. Thank you so much. Thanks everyone for joining. Thank
Yeah.
you.
Yeah, thank you, sir. So in the continuation of this keynote sessions, we have with us Professor Yusuf Mehta, who is the director at Henry M. Ruan College of Engineering, Ruan University, USA, and he would be deliberating on the topic recent advances in transportation engineering creates. So a very warm welcome to you, sir.
All right, good evening.
Yeah,
I hope
good
you can
morning,
hear
sir.
me okay.
Yeah, there it would be morning, and from where I have connected in Malaysia, now it is 9:30 night. So, a very warm welcome, sir. And just to have a brief introduction of Professor Yusuf Mehta, he's the professor and graduate coordinator at Department of Civil and Environmental Engineering, Director, Center for Research and Education in Advanced Transportation Engineering System. He has obtained his PhD in civil engineering from Pennsylvania State University, MS in civil engineering from University of Oklahoma, Bachelor's of Engineering in Civil Engineering from University of Mumbai, India, and his primary areas of research interest are pavement materials and super paved technology, highway and pavement design, pavement management and rehabilitation, modeling of pavement system, traffic engineering, and a lot more. And he has been awarded with various awards. To name a few, it is the Aviation Research Award, which was given by American Institute by Aeronautics and Institute of Electrical and Electronics Engineering. Next one, New Jersey DOT Research Implementation Award for the project title High Wrap in HMA. Then high reclaimed asphalt pavement in hot mix asphalt project, which was funded by New Jersey Department of Transportation. And it was one of the 16 projects out of 120 that were selected for 2012. And a high value research award by AASSTO Research Advisory Committee. He has the teaching recognitions also. So Lewis J. Pignataro Memorial Transportation Engineering Education Award 2013. And this award was for outstanding record of achievement in transportation engineering research and undergraduate and graduate engineering education. Mid-Atlantic American Society of Engineering Education 2008. Of Solid Waste Technology and Management. He is the Associate Editor of American Society of Civil Engineers, Journal of Transportation Engineering. He is also in the editorial board of Modern Traffic and Transportation Engineering Research, MTTEI. So with this brief introduction, I once again welcome Professor Yusuf Mehta to deliberate on this topic. Over to you, sir.
Yeah, thank you so much for the kind introduction. What I'm going to do today is explain the breadth of activity that's happening at CREATE. We will start, I'll present several projects related to sustainable construction materials in detail, but I'll also touch on other aspects of transportation that we are doing related to bridges, geotech, and especially ITS and transportation safety as well. So I plan to give a full comprehensive breadth of the research portfolio that we are handling at this time. The mission of CREATE is to conduct cutting-edge, applied, and readily implementable research in transportation. Most of our clients are interested in making sure that the implementation is comes in within a year or two of completion of the project. That is vital for our sponsors. And we create, in the process, we create a diverse work environment that educates and trains the next generation of professionals. And many of our graduates end up working in a lot of leading federal government, state government, and consulting firms as well. So just to give you a brief overview, we have a certified construction materials lab, and then we got something called the heavy vehicle simulator that could, that's a $3 million equipment at least at that time, and that can apply 20 years of traffic in a few months. And that led to the development of Creates. We started with pavements and construction materials, but now we have grown into a completely comprehensive transportation system, ITS, connected vehicle transportation, safety, bridges, and construction materials. We have several full-time tenure track faculty members and full-time staff. We have research experience for undergraduate and graduate students. We have close to 20 doctoral students, and it's a tremendous growth considering that our doctoral program came up in September 2016. So within short 6 years, we have grown significantly, and we have close to 45 to 50 undergraduate students funded working on this. And we have established partnerships with industry for workforce development, and we have close to 10 to 15 research associates or postdoctoral fellows. And this vehicle, heavy vehicle simulator, puts us in a very unique space. We are the only academic institution in the Northeast that has that capabilities. So this is what it looks like. This is the machine, and you can see there it is a temperature controlled, and you can apply the wheel going back and forth, and it can do 20,000 passes a day. So that's pretty phenomenal. You can imagine that we had all of us do lab studies, computer simulation, but this allows us to answer this very difficult question that agencies are interested, how will it do in the field, right? And this gives you the answer in a few months compared to waiting for 15 to 20 years. So I'm going to weave this into professional development, outreach, workforce development, education, and research. The PH research update, you can see our portfolio within the short 5 to 6 years. We have a portfolio of close to $40 million of research from US Department of Transportation, Department of Defense, which is our current major sponsor with close to $17 million, National Science Foundation and State of New Jersey and other New Jersey Turnpike and other agencies like Rhode Island DOT. We also have industry partners that come to us with, they have a material they want to evaluate, and we are the ones that help guide them how it can be used most efficiently. So this is our research portfolio. And I mentioned a little bit earlier about the Creates graduate students. As you can see, this is within the 5+ years, we have grown to more than 20 to 50%, 20 doctoral students and close to 10 master students in the area of Creates. And you can see the breakdown right there. With this background, we have got a very prestigious Department of Education funded something called GAN, Graduate Opportunity and Safe and Resilience System called GoStars. And this is usually given to fund doctoral students, and that is primarily for US citizens and permanent residents in the area of national need. And we made a case that transportation infrastructure and safety is a significant need, and we were successful in doing that. And also we are funding for 2 engineering educations. And we have a very, very large staff there, and we are growing. This is our snapshot at the last Transportation Research Board meeting, and this is we have grown almost 25% more since the last photograph. So a couple of payment. I'm going to talk a little bit about construction materials. Our biggest sponsor is the Department of Defense, looking at innovative technologies and materials in Arctic region. We are looking at innovative partners, and then recently we got an Ingenuity long-term payment support program grant. So some of the sustainable construction materials, we are looking at using 100% recycled asphalt pavement, which is really unheard of. But for airfield payments, using 100% recycled, we know that we don't get a performance of 20 years, but this allows the Department of Defense to extend the life for 6 to 12 months and allows the operations to continue. So this is very important for the Department of Defense to ensure that the operations are running. Next is warm mix asphalt, and the next is finally is plastics, and we are very aware that India has been very successful in using plastic, especially CRRI and other state IITs and other institutions have worked significantly in plastic. You use of plastic in construction materials, but it has worked well as putting plastics in so-called warm temperatures or hot temperatures like India. But for cold regions, we have to look at the compatibility of plastics with binders. And that's a big challenge because you need that compatibility is very hard to obtain because you will see premature cracking. So we have to add lighter oils, cooking oil to offset the negative effects of plastics to at cold temperatures. So that's an ongoing study, and we are looking to publish some of that at the TR. This is a very, very hot topic called cold in place recycling. You reclaimed asphalt pavement, we add emulsion or foamed asphalt, and it's 100% recycled cold. And as you can imagine, using everything that's come out, you're not wasting any of it. You're using emulsions and using additives like cement, and you can get all of this back in to get a very solid foundation. And this is a very hot topic in the US and other countries as well, because it gives you a very solid foundation. You cannot use it as a surface mix because it doesn't have the smoothness, but it allows you to extend the life considerably. So we looked at the laboratory and field performance of cold CIR and assessed environmental and economic costs, and we developed a combination of the lab of the based on lab and accelerated payment testing. So this is what you can see. You can see that we have an accelerated payment testing facility, and it's a closed loop process. We have this come out, and this is at our creates facility, and it goes back in. We add a little bit of cement, a little bit of emulsion, and we put it back in. And this happened after 2-3 years of lab studies. We came back to the accelerated payment testing to put in 3 sections at the, and we tested it using the heavy vehicle simulator. And this is the machine we use. We use the wet mix, which has a high binder contact, which is crack resistance. Then we have the balanced mix design and the dry CRR mixes pulled in place using the low binder content. So the question comes here is that, okay, in the lab it did well, but what does well mean? Like, how will it perform in the field? That's a very vexing problem for the state agencies. And this is what the heavy vehicle simulator answers, that how many cycles to failure it can handle. So this is what you saw based on our heavy vehicle simulator. You can see the rutting in the field. We see cracking as well. And right here, we did a cost evaluation per lane mile of CIR over conventional mill and overlay, and we saw around 10,000 to 12,000 savings per mile, energy consumption saving of 57 to 60%, and 73 to 80 per tons of fewer emissions. And this is now gaining a lot of steam, not only in the Department of Defense, but also with the Department of Transportation as well. And some of the other ones are coal central recycling, full depth reclamation, and all of those are our ongoing projects. Next one, we are looking at geosynthetic layers in pavements and asphalt. So geosynthetics have been used for years in soils, and it's well known for retaining walls, foundations, and you know. But we are entering a new space by putting that in asphalt. And first thing we have to look at is whether the geosynthetics do not melt at very high temperatures. And this is what we did based on our lab studies. We made these slabs, and we did some cracking analysis. We did some testing, and you can see right here. You can see that this is on the left is a beam without the geosynthetics, and on the right you can see there's a subtle line that you can see is a geosynthetic, and you can see the crack is arrested right there, and it is spread out before it reaches the surface. This significantly increases the life of the pavement, especially in the asphalt, and it allows us to increase the pavement life. A couple of things to look at is not only it should be able to be constructed, but post-failure life. For example, it has to be recycled. It cannot clog the pavers, so on and so. These are very important considerations whenever you put anything in the asphalt, because there's this whole thing, whole mindset of, whether it's stone or glass or whatever it may be, try to put it in asphalt, right? So, but you have to look at the back end of recyclability, and you don't want this, and most importantly, you don't want it to fail sooner, because now you have created another problem. And then we are looking at delamination. Delamination is a big concern, and we see that there was no delamination between the layers, and because delamination will accelerate the failure. So these are some of the delaminations. So then, after looking at 5 geosynthetics, we shortlisted 2 for full-scale testing, and you can see we constructed 3 sections in fall 2020 with and you can see we had 2 layers. You can see on the left side is a control section. There were 2 layers, HMA layer 1 and 2, with nothing in there, but these white vertical are notches, are cracks, and then we put a geosynthetic layer and with a tack coat. So right here you can see these are a construction going on, and we are very highly controlled. We instrument all our sections, and you can see our team is instrumenting all the sensors on either side of the crack to ensure to look at the movement of the layers, stresses and strains above and below the geosynthetic. As you can see it right there. And right here, you can see we are putting in the geosynthetic. We put in a geosynthetic fabric and a geogrid, and on the far end where you see the truck is the control section. This was done in the winter. We wanted that to in cold conditions, so you can see it was in January. We got a few days of good weather, and we could fit it in. And here you can see from the top, this is our construction facility right there. And then we are doing heavy vehicle loading. 250,000 passes at 40 kilonewtons, and then 60 kilonewton, looking at 1.5 million easels at 50 Fahrenheit. So you want to design the experiment in such a way that you find the critical path to failure, and you want to test it at that. And we did heavy vehicle deflectometer testing before and after the HVS, just to look at the in situ moduli of the layers. The next one, which is we feel very proud about, is self-de-icing flexible pavement structures. And we look at the efficiency of using the electricity-based self-de-icing. This is very, very critical for multiple reasons. You are looking at for bridges in cold regions like New Jersey or any northern part. Bridges will freeze over water bodies before the roadway, and that could lead to serious accidents. Also, you're looking at operations, airfield operations during snow events. So you need to make sure that some of these operations are running continuously, and therefore this is going to be very critical. These are not meant for long sections of roadway because they are very expensive, but for critical short lengths, this is going to be very, very useful. So what we did is we are based on our 2 years of lab study, we developed a high performance thin overlay mix consist of graphite and carbon nanofibers. And we use 1% of carbon fiber and 30% by volume of graphite. And we came up with this so-called combination, which had 1 to 2 very low resistivity of 2 ohm meters. And then after that, after our 2-year studies of coming up with this optimum mix, we went into the full-scale testing. We constructed 3 taps, 1 control and 2 electrically heated, and we are monitoring the performance. Right here, you can see this is some of the photos you already saw, and these were our electrically heated strips right there. One was a traditional high-performance thin overlay, and then that's a control mix, and then we had our conductive mix that we made at Creates, and there was one more a proprietary mix that one company was saying. Here it is. This is our construction. This is our carbon and graphite mix, and here it is. So you can see you have to put sorry, I'll go back up here. You have to put you have to prepare the section. It's very, very resource intensive. but you don't need that much voltage. This is a proprietary mix where the companies claim that it can work with any mix as long as they have this material on top of it. And you can see our study, we kind of vary the spacing of these bars to look at the efficiency between 6 inches to 12 inches long. So right there, you can see different spacing levels right there for our control mix. So we put in the creates mix, put 6 inches spacing, and then a foot spacing. And there you can see right there, our first winter, you can see it did reasonably well. And then this is a second winter, as you can see on towards closer to at the bottom. This was a Roman self-de-icing system after a very heavy snowstorm, and then the far end is the control section. So we clearly see that the self-de-icing is working well. And we recently received an award from the New Jersey Alliance for Action for this study. This is our creates team right here. And this is our visit by the congressman with the university president right there. We are showcasing our work for the Department of Defense. And some of the other studies we did was in geotech. We are looking at some education related stuff for mixed reality for integrated geotech education. We are doing wireless in situ payment sensors. We're looking at effect of creep and fatigue in heterogeneous salt, and Camden Health Initiative looking at bioremediation of toxic metal and for the city of Camden. Cementitious material, we are looking at innovative techniques and materials for preventing concrete shrinkage cracking. And as you know, there is a big push by the Biden administration to look at carbon neutral material. As you're aware, carbon is a very highly emissive product to produce, and this is the wave of the future as far as the construction materials goes, and we are looking into that as well. On the bridges side, we have the NGDOT Bridge Risk Force looking at bridge deck surface profile evaluation and rapid screening. And then I'm going to move on to the research area of traffic safety, big data analysis, traffic operations and evaluation, and ITS. So we have just received a grant from Smart and Connected Atlantic City Expressway to look at the Atlantic City Expressway goes from Philadelphia to Atlantic City, and this is a collaborative effort with Rowan University, with Leidos, which is going to be manufacturing the sensors, Kennesaw State, University of Alabama, West Virginia, and Clemson University. And this is to transform the existing expressway into a smart and connected corridor, and to deploy and evaluate cellular vehicle to everything tolling to support future. So they are actually going into cashless tolling, and we are going to use that opportunity to look at other technologies, how we can enable that. And benefits to SGTA to V2I ready infrastructure, cashless tolling, optimization for existing resources as well. And of course, benefits to users, cashless tolling and support for conventional vehicles and future vehicles, reduce congestion as well. We are going to do some congestion pricing. We are looking at if we can help lower the tolls are pretty high on the Atlantic City Expressway, and we are going to find ways for people who go out and work at these casinos, we can find a more cost-effective way of tolling for them. So easy pass tolling, we are looking at current technology, and then next generation CV2X tolling, congestion pricing, and asset management. So this is something I'm going to talk about in the next few slides. One of my team members, Dr. Jalaya, is working on artificial intelligence video analytics system, looking at non-compliance such as red light running and pedestrian jaywalking at intersections. And this is a worldwide problem. And especially we are seeing a lot of pedestrian fatalities, and part of it is also pedestrians at fault because they cross very distracted with phones in hand and so on and so forth. So right here you are looking at pedestrian jaywalking, vehicle red light running, and they are looking at machine learning and real-time analysis to do that. They're looking at signal performance measurements as well, funded by the New Jersey Department of Transportation, and real-time traffic signal performance measurements. So one of the key things we looked at a novel approach to identify distracted driving, and we are very proud of the study. This was funded by the New Jersey Division of Highway Traffic Safety, looking at AI framework to detect and classify distracted drivers. A very complicated subject to quantify, right? People are not going to claim that they're driving distracted. So it required a lot of thinking on how to design this experiment. So you need to take photographs from a distance, and then you have to use machine learning to identify what is actual distracted driving to normal behavior. So you can see people holding the phone, eating, fidgeting, receiving calls, and this was done completely on machine learning. And this was a very well published, we got a lot of press from this. 1 in 5 motorists on the roadway are driving distracted, higher on the weekdays than on the weekends. They are receiving calls, texting, eating, grooming, higher on weekdays than on weekends. And a lot of talking to passengers was higher on the weekends because they're not in a rush. And so there are some serious problems. 1 in 5 is significantly high. It's like a ticking time bomb. Accidents are waiting to happen, and they are happening. Some of them are fatal. This is something we developed at Creates. This is a mobile data collection system, and this could be effective in a lot of countries, including India. This is a very low cost, cost-effective asset management system. This can go on any vehicle. It can be done just based on a cell phone. You can just attach it to any system, and you can drive. And it takes photographs it takes photographs of the roadway, and then you use machine learning and use image processing to rate the system multiple ways, right? You can have a very complex system or a very simple, low, medium, high, and this is what you're looking at. So simple phone-based system, and it takes pictures on that, and you get a system overview. And we are doing it for counties and local governments, which don't have large budgets, right? So this is very critical. And larger agencies have a $500,000 to $1 million budget to do a full-fledged annual asset management. But for these counties, any kind of quantification will kind of gives them credibility to ask funding from the state agencies. So collect payment distress, we are doing that, analyze the data, and develop a user-friendly collection, and develop a new payment conduction index. We have done the equipment purchase, data collection, and data analysis, and finally we are doing the mapping as well. Some of the other program, we are doing the New Jersey underserved community electric vehicle program, Camden Hill, looking at smart and sustainable public transportation system as well. And first and last mile, this is something we is also very critical, especially in cities where not many may, in the US, there's this perception that everybody owns a car, which is for the most part true, but there are certain demography. For example, in Cameron City, 58% of the households own only one or no vehicles, and people have to get to school or doctor's appointments, and so this is called the first and last mile problem, where the first and last mile are the shortest. That means from home to get to the bus station, to get the train station. They are shorter distances, but they take the longest time. And the same is true on the other end, right? Something that we take for granted in the metropolis in India. But we have to look at the safety. Can the school kids go to the bus station safely? Can elderly that need to go for chronic regular doctor's appointment for chronic diseases can get to these doctor's appointments safely? So if you don't have these done very easily, if it's not accessible, people are not going to take these appointments, and they're going to fall sick, and mortality is going to rise as well. So we feel very proud of the study. We have come up with very strong recommendations, and most of these are not engineering problems. They are more public policy problems, such as providing free shuttles, and that includes resources and pricing issues and so on and so forth. But we are doing the engineering part of providing appropriate lighting and so on and so forth, regular enforcement in certain key areas, because again, these things cost money, and where to allocate those funding. So a quick education, we do a National Summer Transportation Institute. We kind of excite high school students about transportation in the summer. We have other geotech related, you can read their education activities as well. And these are some of our National Summer Transportation Institute programs. And right here we are presenting that as well. And we did some phenomenal hands-on studies as well. And then we are providing a fellowship program and the summer internship program as well. Thank you so much. I covered a lot of ground, but I'm not sure if I have time for questions or there's space for questions. Thank you for the opportunity.
Yeah, thank you so much, sir, for such a wonderful and informative presentation. And we value the time that apart from your hectic schedule, you spare time for us. And we would like to express our deepest gratitude for your presence to our fourth edition of International Conference on Trends and Recent Advances in Civil Engineering, TRACE 2022. Your remarkable depth of understanding of the subject made the session an exceptionally stimulating and informative one. So thank you so much, sir, for deliberating in depth on the particular topic. And with this, we are ending this keynote session. And before I end, we'd like to propose a vote of thanks to our knowledge partners, that is the Global Council for Science and the Environment. So lot many collaborations we would be seeking in your future with this GCSE. And moving ahead with our different session, and there would be the keynote address based on the theme Climate Resilient Built Environment by Global Council for Science and the Environment, USA. And the deliberation would be taken up by the keynote speakers, Dr. Esther Obnoy, Associate Professor Director, Global Building Network, Penn State University, USA, Engineer Given Justin Mina, PhD, Landscape-Based Stormwater Management Expert and a Lecturer, Department of Environmental Science, ARDHI University, Tanzania. And the third keynote speaker, Mr. George Forden, Researcher, Loughborough University, UK. So we extend a very warm welcome to all the guests who would be deliberating their keynotes on the topic. So before they start the session, I would invite our Head of the Department, Dr. R.K. Tomar, and Deputy Director, Dr. Madhuri Kumari, to brief about the session in detail. Over to you, ma'am.
Thank you so much, Dr. Priyanka Singh. Before we begin the session, I'm sorry, I would like to request Dr. R.K. Tomar sir to say a few words, please.
Yes, I welcome all of you to this session. Yes, I think it will be a very informative lecture or a panel discussion on this eve. Thank you, ma'am.
Thank you so much, sir. So once again, before beginning, may I take this opportunity to thank Professor Yusuf Mehta. Sir, thank you for your support, for agreeing to our request. And I was just listening offline to your lecture, and it was indeed very informative. Even though we interact less, but I think there are a lot of areas where we should start interacting more, because I can see a possibility. I think the ocean of possibility, I should say, not just possibility, to collaborate and also to share the knowledge with the students and the faculty exchange program. So we'll definitely talk more with you, sir, so that, like sometimes the collaboration gets into a dead mode, but then we again need to bring it back. So thank you once again, and good day to you.
Thank you.
I'm so delighted, and I would definitely want to tell audience like how helpful and how grateful I should be to the Global Council for Science and the Environment, who were instrumental in putting this panel discussion at a place, and this was actually driven, I would say, yeah, driven by Dr. Esther Obonio, who is Director of Global Building Network, Penn State University, USA, and she is also a Senior Fellow of GCSC. So before we begin this session, I would like to introduce to the participants about this council, Global Council for Science and the Environment, who are the knowledge partner of our 4th International Conference, Trends and Recent Advances in Civil Engineering, TRACE 2022. GCSC is a non-governmental organization which was established in 1990, and it advances the use of science basically to inform the environmental decision making. The work of GCSC spans boundaries between science and decision making, and to strengthen the impact of durable solutions primarily to the environmental challenges. Their vision and mission is aligned along the Sustainable Development Goal of United Nations. GCSC engages scientists, educators, policymakers, business leaders, and officials at all levels of government. So it's indeed a privilege to get associated. We are actually working very closely with GCSC. Amity University works with them in terms of being their consultancy partner. Now, without any further delay, I would now hand over the session to the session chair of this panel discussion, Dr. Esther Obonio. So over to you, Dr. Obonio. Thank you so much to all of you for sparing your valuable time.
Thank you, Dr. Manduri Kumari, and also to Amity University and everybody really for making time to join our conversation this morning. I'm going to start off by introducing myself, then I'll introduce the speakers. So as you heard, my name is Esther Bonyo. I'm an associate professor jointly hired by Engineering Design and Architectural Engineering at Penn State University. I'm also currently directing an initiative that Dr. Manduri referenced earlier on, but I wanted just to highlight the fact that it's a global building network. We are building partnerships. We are trying to help efforts that are directed at decarbonizing the built environment in a climate responsive manner through partnerships. So we are open for conversations. We're open to having conversations with those who are interested in joining us, whether it's through research, through education, or even dissemination. If there are things that you're doing that we can learn from, whether they worked or not, we believe that through making these connections, we can hasten the speed at which we are making the built environment more climate change responsive, while also protecting the people who are most vulnerable. My own research focuses on the resilience of low-income housing. I started off by looking at the engineering dimensions, and I'm still continuing to do that, but I'm increasingly broadening the focus area to include the social sciences, the health sciences, because of the interdependency and the interconnections of these systems, the different systems which result in people who are living in low-income housing being vulnerable. I'm going to move ahead now and introduce the first speaker. So we have George Forden. George Forden is someone that I met actually through a colleague, a collaborator at Loughborough University. I was looking for a partner for the Global Building Network, and based on what I shared, he introduced me to George Forden because at that particular time, George was working as the humanitarian program lead at BRE Trust. And his focus there was developing partnerships to support humanitarian shelter and settlement action in the post-disaster context. He is also a trustee of the Kanji Project, which is a charity that supports education and poverty alleviation in rural Tamil Nadu, India. Currently, he's enrolled at Loughborough University as a postgraduate researcher, but the most interesting thing happened when George moved from BRE Trust to Loughborough University. They gave him the program that he was managing, one of the programs that he was managing that he's going to talk about today. It's called QSAND. They gave it to him, and they told him, can you go to Loughborough with it and continue managing it from there? So George, welcome. We're excited to have you. Thank you for responding. You know, when I reached out, he responded right away. He said, absolutely, I'm going to do this. I don't know if we have Givens. Given, are you here with us? Did we
Yes, Esther, I'm here listening you.
Yeah, Given is joining us from Tanzania. He may be having limited bandwidth. If you cannot turn on your camera, it's okay, don't worry about it. But if the connection is stable, please turn on your camera. Given Muhina is also a very close friend and collaborator from Tanzania, he trained as an environmental, he trained in the area of environmental science, environmental engineering, environmental management. He also has professional experiences in this area, urban ecosystem restoration and disaster management. He is currently working as a lecturer in the School of Engineering, Environmental Science and Technology at Al-Azhar University in Dar es Salaam. I also know Givens through the Institutes for Building Research. Given, are you still there in the Institute for Building Research? Yeah, so within the Institute for Building Research, they are looking at sustainable building technologies and materials, and they do a lot of outreach, working with communities throughout Tanzania, helping to disseminate the findings from research with respect to materials and technologies that are appropriate for use in Tanzania. Some of the places in Tanzania are very vulnerable to flooding, and some of them also are dealing with extreme heat problems. So thank you, Given, for agreeing to join our panel this morning. We are going to start with George. Can you please give us an overview of some of the work that you've been doing since BRE, when you are at BRE Trust, but also the work that you're continuing to do? Can you please share some of your thoughts and experiences with us, please?
Yeah, sure. Thank you very much, Esther. Hopefully you can see my screen now.
Yes, we can.
Yes, we can see it, George.
Great, thank you. Yeah, so I'll just give a really quick presentation on a little bit of information about the QSAN sustainability tool that Esther mentioned, and hopefully we can talk a bit more about this in the discussion as well. But just as a kind of an introduction, QSAN is a free-to-use sustainability self-assessment tool, and it was designed for post-disaster reconstruction. It's based on the principles of BREEAM, which I'm sure many of you are aware of, the Building Sustainability Standard for the built environment, but specifically applied to humanitarian response and recovery contexts. And so we're looking at kind of immediate humanitarian response all the way through to longer term reconstruction and recovery. And it takes a holistic sustainability approach. So we're looking at environmental, economic, and social sustainability. And for me, sustainability means the capacity for a disaster affected community to not only survive, but to prosper in the long term. You can see in the bottom right there that resilience is a cross-cutting issue within QSAN. And I think that I would argue that building resilience is a key precursor to being able to consider sustainability aspects in shelter and also just in projects in generally. If it's not resilient, it can't be sustainable. And I think that as well as that being a precursor to sustainable shelter, the community resilience itself can be supported by shelter action and shelter response. And so QSAN is designed, as I mentioned, for use in a displacement or a post-disaster context. In the immediate early response phase to disaster, you can use the pre-assessment tool as a checklist to effectively make sure that the decisions you're making in immediate response don't have negative long-term consequences. So it might sound really obvious, but there's several examples of humanitarian organizations putting temporary shelter in the same location where they're intending to build longer term housing. And obviously that causes problems for being able to engage in reconstruction and things like that. So the pre-assessment tool is for that kind of immediate disaster response phase to start to think about the longer term decisions as you're making kind of emergency response decisions. And then the key part of the tool really is the core assessment tool, which you can start to use to assess the sustainability of your project as reconstruction occurs. And this is really where the assessment comes in. And you can assess the sustainability of your project on all of the issues that we saw on the previous page. So that's everything from natural environment, access to energy and water and sanitation services, looking at waste management, and all the way down to kind of the social impacts of the shelter impact and what the impact of the shelter response is having on the community. And I think really what QSAN is designed for is to support decision making, and in order to do that, it uses a balanced scorecard approach So there's a lot of information on this page, but effectively you're able to define which issues are within the scope of your study based on the priorities within your study. So for instance, if you're rebuilding in a formerly settled neighborhood somewhere where the people that live there own the rights to their land, then maybe an issue like security of tenure within QSAND is less relevant. Whereas if you're working in informal settlements or in displacement contexts and you're rebuilding in a new area, something like security of tenure becomes really important, making sure that people have the rights to the land that they're on. So depending on the scope and the priorities of your study, you can prioritize different issues to assess and then identify key performance indicators within that. So the idea is you define the scope of your study, you identify what it is you want to measure, you give a relevance factor to each of those KPIs that you're looking at. And then you would expect that something that's been rated as of greater relevance to your project or a higher priority, you would expect to perform better because that's kind of core to your project goals. So that's kind of the system that QSAN tries to use. And really it's a way to support decision-making and help with prioritization of issues when there's so many things to think about in disaster response. And really, I think the most important factor that QSAND aims to demonstrate is that shelter or housing is a lot more than just 4 walls and a roof. It's a process, and shelter is constantly being updated, changed, used by the people that live inside it. And the way that shelter is provided or built has impacts for beyond just the structural resilience of the building itself to a lot wider group of issues. And so really my PhD research is particularly focused on this bit in the middle here, kind of I'm looking at community resilience. And I have a paper coming out tomorrow actually in the Centio Journal where I discuss what constitutes resilient housing in humanitarian contexts. But in short, I think addressing this middle section, the process through going from a displacement context into a permanent home for people, the way that happens and the process through which that occurs really contributes or takes away from community resilience. And that's what my research is looking at, and that's what QSAND can actually hopefully help with. And so just to sum up, I think that good quality, sustainable shelter and settlement programming has a huge number of impacts for the wider community beyond just the housing group themselves. And this report from Interaction covers the wider impacts in a lot more detail. But I think a good core component is just looking at community needs, engaging with those affected, and prioritizing long-term community development from the immediate response phase of a disaster all the way through recovery. I think that's probably my time, but if you've got any questions, I'd love to talk more, and my email address is on the screen. But thank you for listening.
Thank you, George. Thank you, George. Powerful presentation. Some of my favorite moments include the slide where you talk about shelter as a process, and we're going to come back to that during the Q&A, but thank you, George. I'm going to invite Dr. Given Muhina to also share some thoughts based on his experience.
Okay, thank you very much, Esther. I also have a very short presentation, a 5 minutes or so presentation. And in this I will be sharing with you experiences that we had from a project which was known as Water Resilient Green Cities in Africa, which was implemented by Arith University in Dar es Salaam, Addis Ababa University in Ethiopia, and Copenhagen University in Denmark. This was a 4 years project, but mainly it meant to identify opportunity for adoption and implementation of nature-based solutions as a way to improve the adaptability of the city of Dar es Salaam to weather-related disasters, hazards, and risks. Now, the interest to the objectives of this project actually was evoked by the first urbanization of the city of Dar es Salaam. And in so doing and doing this project, it was revealed that when you are talking of urban hazards, urban risks, and all that are related to extreme weather changes, they have a very close collaboration with what is happening in terms of land use changes, and loss of green spaces in the urban Dar es Salaam. But that being the case, when these two major issues going on, meaning the land use changes keep on going as a result of urbanization and loss of green spaces as a result of extreme weather events, in this case, extreme prolonged droughts in the city, it actually results into one major impact, which is increased diffraction of impervious surfaces in the city, of which from there you get so many other climate-related hazards that comes in. That includes issues like increased urban heat island, increased soil erosion, but most importantly, the increased frequency of floods, but again, the increased intensity of floods that occurs in the city. And you find that when you are looking into the literature, you will see that most of these challenges are actually related. They have their roots down to the mismanagement of urban stormwater. And you find that if you have a solution, if you have a way to better manage the urban runoff that keeps increasing as a result of impervious surfaces increase, you can also address so many other synergic challenges, as I have just said. Now, we actually used in this project a methodology which was known as a design challenge. This is a very common methodology that is used to engage the community even better. We wanted to see what are the response of the people. What do people say about what we find as a problem that results from climate change and increasing urbanization of the city of Dar es Salaam. Now, from this slide here, you see that we tried to link from the response of the people, what is the most severe challenge in terms of climate-related hazards in the city. And you will see that soil erosion was linked as both the most severe and the most prevalent problem in the city as a result of climate change, but again, as a result of fast urbanization of the city. But this also tells us a lot that when we were actually concepting the problem, I mean the research, you find so many other issues that were mentioned by the community being a problem in the city were also within the challenges that are commonly from the fast urbanizing cities of Africa, as I have shown in the area slide. Now, in response to this, we actually did some cross-sectional and transverse survey within the city, where we could also see so many other nature-based solutions that are being implemented here and there in the city, but not in a very structured way. But at least it was an indication that nature-based solution is also found by the community being a way to improve the resilience of cities towards climate-related hazards. And this was a good thing, but we wanted also to see what is the motive behind the few nature-based solutions that are existent in the city. You'll find that most of these nature-based solutions that are mostly implemented in the city of Dar es Salaam actually includes things like greening, okay, using various vegetation, but the increase of the use of gravel lawns for aesthetic and scenery improvement of different houses in Dar es Salaam. But also we found rainwater harvesting as being one of the nature-based solutions that is widely seen in the city. Now, only seeing that these are issues that are actually being seen as issues of concern by the community, we wanted also to see what are the drives, what drives them, what motivates them to putting in place these few nature-based solutions that we see in the city. And there were a number of reasons among those, but since Dar es Salaam is still having issues with water supply, you will find that water scarcity was one of the biggest drives, but also the improvement of scenery using these different nature-based solutions was among the motives for putting these nature-based solutions in the city. Now, this in its own right, it actually proved that not only we as the scientific community finds nature-based solution as a way towards improving the resiliency of our city, but also the community finds the same. But that being the case, why then we have this rudimentary dissemination of these different options? Now we found so many challenges for the same, and those challenges were mainly clustered into three, that is individual challenges, but there was also an issue with interdisciplinary challenges that are also one of the causes. But again, you find that these different disciplines, they're actually not working together. But apart from that, we went into looking into general causes for this rudimentary or less dissemination of these nature-based solution to really make an impact in the city. One of those reasons was conflicting mandates of different actors. That you find many of these actors within the city, they are actually working in silos. Everybody is doing what finds is right, but there is very little coordination between those actors. Another issue was partial ownership and absence of guiding frameworks of these different efforts that we find in the city. But the other issue was poor coordination among coordination of nature-based solution among the actors. And the most important one was inadequate recognition of these nature-based solution into the policies and legal provisions as a country as a whole. However, there are a lot of initiatives to make sure that we have a framework that guides and puts together all these initiatives. But all in all, nature-based solution, it might find its way into the general development activities of the city as a way to improve resiliency to this. With this, a few remarks, I think we might have more when we come to the questions. Thank you very much for listening.
Yeah, thank you. Thank you, Engineer Muhina. So I was born and brought up in Nairobi, Kenya, and I remember a workshop that we had 3 years ago, no, before COVID, 4 years ago, where the challenges that you're talking about came up, and the community members, the response for the community members, they were the context within which we were discussing community participation was flood management. If you've ever gone to Nairobi during the rainy season, you know that the flooding that hits downtown Nairobi is getting worse and worse every single year. And what I found fascinating, if you can stop sharing, given then we'll see everybody better. What I found fascinating was there was consensus across the board on one fact, that the more we construct, the more we transform the agricultural parcels into apartment, residential areas occupied by apartments, the more road construction happens, the more the flooding occurs. So the reason why I bring this up is the community members keep saying the same thing. Even when the news journalists are in front of them with their microphones, they keep asking, where are the engineers? Yeah, because for them, it's like, this is a very easy problem to solve. 1/2 of the year, we don't have water. The other half, it's too much water. So they're like, this is very simple. Engineers need to capture this water so that it doesn't hurt us. And then at the same time, during the drought, we have no problem of water scarcity. So I'll actually start with you, Engineer Muhina. What is the problem if this is that simple? Like, the problem is known. We have drought and we have too much rain, all occurring within the same year. Why is my grandmother not getting what she is asking for? Like, we have smart engineers like you, Givens. Why don't we just capture this water?
Yes, Esther, that is a very candid observation for many cities here in East Africa, that we have this back-to-back problem, okay, of water scarcity, but again, flooding. But the issue with engineering, the contemporary engineering solutions that might work for this, one of those should be the use of nature as a laboratory to solving these problems. But for these small initiatives like rainwater harvesting, using our roofs, issues like using detention ponds and the like. For them to make a bigger difference, they really needed to have some kind of correlation, some kind of aggregation, so that they bring about an impact. But whatever you find in the city, those who are actually adopting this as a way to solving the problem are very few. And there is no framework, there is no strong regulations to aggregate these small efforts that are happening here and there so that it can bring about an impact. So the main issue, if you ask me, it is the desegregation of these efforts. Those few who really appreciate that these small nature-based solution can actually solve issues with water supply, they actually don't have the mandate to actually mainstream enough budget so that it solves the problem to an extent that can be appreciated. But those, the majority, meaning that the community, who are very big contributors, if at all they are taken into board, they are very little engaged in terms of how to guide them use these different solutions in their daily activities. And one of the issues that came out of the project I was sharing the experiences from, we found that for these small initiative to work, they really needed to have the initiative of the three, meaning that the politicians, they also needed to really find that this is an issue that needs to be mainstreamed in the development, the research community, the same, and without forgetting the effort that the community has as they keep urbanizing the city.
Thank you, Engineer Muhina. I'm going to move to you, George. So I would like you to share with us an example of a project where the QSAND has been used, and as part of your response, also reflect on the scaling challenge. What needs to happen to take the kind of impact that QSAND can make from a small effort to something that can be deployed, say, throughout India or throughout Tanzania, throughout the US? What do you see as the pathway to scaling the contributions of tools such as QSAND?
Sure, thank you, Esther. And I think I'll give a quick example of somewhere where QSAND has been used. I guess what's maybe most relevant for this discussion would be its application in Nepal after the 2015 earthquake. We were working with Catholic Relief Services, who were engaged in kind of a shelter response project in Gorkha district in Nepal, and they were trying to kind of find a way, because so many people have been affected, to scale up their impact without having to commit significantly more resources, and kind of finding ways rather than just delivering shelter. And this maybe goes to the point that I raised in the presentation about shelter as a process rather than delivering the shelter as a finished product to someone, actually looking at what are the ways that could be applied more effectively. And one of the things when they did their initial QSAND assessment of their project plan was seeing that there hadn't been as much engagement with local communities as there could have been. They'd certainly done a lot better than a lot of other organizations in terms of connecting with communities that have been affected. But in terms of looking at aspects like capacity building and working within communities, that was something that they hadn't quite figured out how to apply effectively. And so that was raised by the QSAND assessment that they did, and they actually ended up engaging in a series of training programs looking at earthquake-resistant design approaches to housing. And so that was something that QSAND had kind of raised as an issue, was the level of capacity by masons and other kind of professionals working in the rural areas in Nepal that maybe didn't have access to the same training that people in the cities did. People in Kathmandu knew how to do these things, but out in kind of rural areas, there was less access to that kind of training. And so actually more important than the delivery of houses was the delivery of training so that people could understand how to do that building themselves, and also how to maintain those buildings. And I think to kind of jump off on the back of the previous answer and that previous question of why are some of these solutions not applied? And I think it's relevant. This is an example where QSAND wasn't used, and maybe actually it could have helped. But my current PhD supervisor, Lee Bosher, who you know, Esther, he did his PhD research in Andhra Pradesh in India, and one of the things that he found was he was in a location where houses had been destroyed and damaged by a cyclone. And so what the humanitarian organizations and agencies that were on the ground went in and did was build cyclone resilient housing, i.e. they built strong concrete houses that wouldn't fall down the next time a cyclone came through. And that seemed like it had solved the problem that had been caused by this cyclone before. But a year later, or a couple of years later, when Lee was out there doing his research, he found that people weren't living in those concrete houses. They were actually, they'd rebuilt their original shelters next to these really heavily engineered shelters that had been provided for them. And in part, that was because whilst they were resistant to cyclones, they weren't appropriate for living in for the rest of the year. It was too hot inside. There was less protection against mosquitoes and other kind of threats that were a bigger hazard to the people living in that area than cyclones, which came around at a certain time of the year. And by focusing on that one singular hazard, some of the wider resilience factors that go into housing were missed. And so I think to kind of go back to the question of scalability and things like that, I think first of all, and it's something the humanitarian sector in particular has trouble with, is there's no one size fits all solution. And the best thing that you can do at the start of a project like this is engage the community. They know best what the biggest threats and hazards are. And maybe you can then do is provide guidance on how to respond to those hazards more effectively. But without that community engagement in the beginning, you're likely to create solutions to problems that are not the main ones that are being focused on. And so I think that kind of community aspect is the key to any project success. Oh, you're muted, Esther.
Yeah, thank you for sharing those experiences and the examples of the projects as well. I'm reflecting on the statement you made about the cyclone resilient housing that ended up not working. I'm going to be talking to a group of people who are working in the space of indoor air pollution and clean cook stoves. And I bring this up because I was also very interested in trying to find out what people who live in those households think about the cause of the problem as far as indoor air pollution is concerned. And we know this is a problem that's linked directly to climate change because wood fuel systems are being used, and there is hope that by connecting it to the environmental health crisis, to the human health crisis, then people will change the way they are cooking. So I bring this up because when I eventually found a paper that talked about the community members' perspective, their first culprit, the culprit that they identified as the main contributor to indoor air pollution problems was actually industrial activities. This was in the context, of course, of urban cities. And it's actually true that the amount of pollution that's coming out of the industrial plants is way, way more than what this small community is contributing in terms of air pollution. But then the second problem that they brought up was water and sanitation. I knew that there was a relationship between air pollution and water, and I was still thinking about it until I read this paper, and I'm like, oh no, I don't need to worry. They've already identified this as a problem. The community members know the problems, and most likely they know what has already worked and what hasn't worked. And we are missing the opportunity to build on this knowledge. Given, I want to turn back to you because you've been involved at this level of listening to community members and co-creating solutions with them. Are there examples of places where people can go and find data that already exists that we can learn from, even if it is focusing on one part of the world? I think it is still important in terms of helping us learn community engaged research methodologies that can work. Are there places, or is there a pathway to accessing information that people like you, people like George have already collected?
I'm not that much sure if really the community, so to say, has access to this kind of information, speaking from the experience of East African cities or urban areas in East Africa. That I think is a bigger problem. When you are talking of access to data, for us here is even a challenge, not only to the community, but also to even the research community. If you go to those who are very much concerned, very much invested with what they are supposed to give us, those kind of data, you find what you have, either the data is not very much stored, or very outdated, or no data at all. If I'm talking of a community center where probably it might you might get enough data and might be of help to the community, maybe to, for example, in Dar es Salaam, if you're talking of the meteorological center, that's where you might find some data, which they often give the community for those who are living in areas that are very cold, and for those who are living in areas that are very hot, like Dar es Salaam. They will always post data like drink so much of water, and make sure you bring water when you sleep so that the dust can be trapped. You don't have so much indoor pollutants into you. And for those who are living in colder areas in the high-range regions of the country, they will always give them information like you shouldn't go to sleep with your charcoal stoves with your door closed, because it will increase the level of indoor pollutants in there. So that is probably what I might say, as they are trying their best to being a center for the community to get information, but we don't really have a very good record of data, so to say.
Thank you, Given. So even here in the US, there's been a lot of conversations about the need for open data, the need for knowledge sharing platforms. And I think it's, you know, the same words, silos. We're working in a siloed manner. We are stuck in pilots. And we really don't seem to have any easy answers to this problem. I know we are kind of coming too close to the end of our time. Dr. Manduri, when is the hard stop? We started a little late. So when do we stop? How much time do we have?
We can go till 8:30. So I can see by clock we have 20 minutes to close. I mean, the hard close would definitely be 8:30, but it's absolutely okay.
Okay.
So,
all right. Yeah. Thank you for clarifying. So the question that I wanted to ask George is related to, based on your experience of working within the humanitarian shelter cluster, are you seeing some examples that we can learn from with respect to creating these knowledge and data sharing platforms or communities? And there are two levels. There's the one that can be accessed by people like myself and Dr. Manduri, Dr. Givens, but I'm thinking about also platforms where this two-way exchange with the community members can happen. Can you please reflect on this question based on your experiences and your ideas?
Yeah, sure. Yeah, I think the question about data is a really important one, and I think I agree with everything that's already been said. It's very difficult to have good quality data, the sort of data you would expect, certainly in an academic setting, in the context where the humanitarian sector works. And actually, one of the humanitarian sector works under what it refers to as a good enough approach, meaning we know we're not going to have data that is 100% accurate, but if we can have data that's good enough to help support decision making, then that's all we really need. And taking additional resources and time to kind of focus in on the very, very specific data that you might expect in an academic setting, or for example in kind of when I worked at the BRE, to fill out the BREEAM assessment forms to get the BREEAM qualification, you need very specific data on the materials that you're using and the indoor air quality of the buildings that you're working in and things like that. As an example of one of the ways that's worked in the humanitarian sector, we developed a carbon calculator tool, because the minimum humanitarian standards were updated in 2018, and they added a metric for assessment that looked at the carbon impact of shelter materials in terms of carbon equivalent emissions created by the materials that were being used. And everyone said, well, that's a good thing to know, but actually it's much less important than all of the other things that you're looking at when you're looking at getting shelter to people that have lost their homes. So we don't want to be doing a full life cycle carbon impact assessment for every shelter material we're using. We want something that's quick and easy to give us an idea. And we developed a calculator called the SMAC carbon calculator that basically used open source data from the ICE database and other kind of carbon databases and environmental product declarations that were open access and available, that provide, you can compare two different shelter types in terms of what they score on that database, which is not necessarily accurate to the actual carbon impact of the materials used, but it gives you an idea, and that helps you to inform decision making, which is where that balanced scorecard approach comes in. So I think the kind of the good enough approach is one that the humanitarian organizations use, and that's maybe the first part of that question about humanitarian organizations, researchers looking at those kind of contexts. That's the kind of data that they tend to use. In terms of data sharing with affected communities, that's something that I think there's a lot of very different ways of going about it, and I think we as a sector need to get better at. There's a lot of kind of form-filling exercise that humanitarian organizations do in terms of, have you engaged with the community? Have you done environmental impact assessments of the area? Have you spoken with community members about what their priorities are? But unfortunately, a lot of the way that humanitarian kind of actors are forced to respond by the way the system works is they get their targets are set by donors and by governments, by policymakers, rather than by the community themselves. And there's been a huge amount of discussion about that in the sector. It's a problem that everyone kind of knows is there, but we haven't quite figured out a way around it at this point in time. And I think it's probably an issue with every kind of sector that works at a global level and tries to apply itself to local issues. But if anyone has any ideas on any of that, then I'd be really, really pleased to hear them.
So Gibbons, Engineer Gibbons, you work for an organization. Thank you, George. Thank you for sharing those thoughts, and they were very insightful. You work, Gibbons, you work for an organization that has a national mandate. So the organization that Given works for is called the Institute for Building Research, one of the places where he works. He's an instructor, he's a faculty member, but he's also working for an Institute for Building Research that previously used to be under the Minister for Housing, and it had the name National Building Housing Research Agency. So that was up until a year ago. They were a standalone entity that has the mandate of providing guidance and helping set the agenda for appropriate use of materials and technology. Of course, this is being done with environmental sustainability in mind, balanced by the need for affordable housing in a rapidly urbanizing context. I'm wondering, given the experiences that IBI, the Institute for Building Research, is building on, does it have any examples of this engagement with the community members in terms of helping bring the voice of the citizens back into the government research and development agenda setting? Or was it one way? Are you facilitating two-way exchange, or is it one way?
Sure. One of our objective at the Institute of Building Research is actually to disseminate whatever we find in terms of making resiliency of our construction technology in terms of housing here in Dar es Salaam. But when it comes to engaging the community so that their voices are also part and parcel of what we are doing, we might say we are actually telling in that regard, because when it comes to issues, when you want to engage the community, it has an implication to the budget, because moving from what you're doing as a research to dissemination of the information to the community, you need platforms like radio stations, you need platforms like community meetings, you need those platforms like TV shows and the like. But again, we also try whatever we find as very useful to the community, trying to disseminate those using the mobile application, because most of the people here in Dar es Salaam, they own mobile phones. But that is at a very elementary level, at a very elementary stage. But we are trying our best that we take on board the people's concern and what they find it working. But if you are talking of using the community as a platform to sending our research findings, I might say, for example, when we are actually trying to go as low as possible in terms of the complexity of technology, in terms of construction of housing, that's where so many people within the community tend to adopt what we do. And when the demand rises up, you find we sometimes get backup from the government, and that becomes a way where people can also be included or taken on board as a way to raise voices on what we do as something good in terms of improving resilience of the city when it comes to improvement of building materials and their efficiency.
Thank you, Engineer Muhina. So it sounds like there's a new profession that needs to emerge within our built environment discipline of customer satisfaction, right? Like there's no profession outside of us, outside of engineers, architects, the other professionals, including even my doctor, you know, after I leave, there's a customer satisfaction survey that comes out and asks, you know, are you satisfied with what you got? And, you know, half of the times I respond, half of the time I don't respond. But I think, like, in addition to the user requirement capture, we need to be thinking about these feedback loops, not just at the very end, but during the entire process, going back to what you said, George, about shelter being a process. If it is a process, then it needs to be continuously improved. And we are going to struggle to have these continuous improvements if we don't have these feedback loops. I'm going to move on to a question that's been posted by Dr. Manduri. And George, since you have a background in the social science, I think you should have the first go at this. Can you please provide insights on the connection between social economic condition of community and resilience building? So while you're at that, please also define resilience.
Two big questions there. Thank you, Dr. Maduri, as well. It's a really interesting question, and I think resilience is something that can be defined in a million different ways, depending on the way that you're looking at it. For me, and particularly in terms of community resilience, I think the most helpful way to think about it is the capacity of the community as a whole to be able to respond to, adapt to, and get through various different hazards that they might be affected by, whether that's kind of natural hazards like flooding and things like that, or kind of more human-made things like conflict, and what is it that is the community and everyone within that community able to weather the storm, as it were, and get through the other side without too much of a hold up or a disruption to their own life and livelihood. And I think in terms of the socioeconomic condition, that's obviously very important. If you have access to better kind of resources, then that's one form of capital that can be used to build further resilience. But actually, one of the things I'm interested in my research, and so I don't have a definitive answer for this yet, but what I'm starting to think about and starting to hopefully argue is that the socioeconomic condition is perhaps less important than the links between community members and this kind of idea of social cohesion. If you have a group of people around you, or both within the community in the geographic location, but also more widely. There's a lot of research on kind of diaspora communities supporting people back in their home country when something's when they've been affected. Those kind of social networks and social links are a more important factor than socioeconomic conditions. One of the kind of early examples of this is I'm doing a bit of research at the moment looking at housing, land and property rights in Malawi, which is slightly different to the socioeconomic conditions that you're mentioning there, but it's kind of widely assumed in the humanitarian sector that if you own the rights to your land, that you're more resilient to disasters that might happen. In Malawi, there's an interesting kind of dynamic in that there are a lot more women that own land, and there's a lot more female-headed households than in other countries in the region and other countries globally, and that's because of the way that the land system works in Malawi. And yet, often female-headed households have more of an issue in responding and recovering from disaster, and the argument there is that it's because of a lack of links to government initiatives, to kind of the people in power in communities that are able to provide support and facilitate reconstruction and recovery. So I think that the socioeconomic and the policy rights that people have and the economic conditions they're in are really important, but they're probably not the most important thing. But I'm at the very early stages of that research, so that might change.
Yeah, thank you, George. Thank you, George. So there's actually evidence even within the US and other countries that shows that people who are closely knit as a community do well. Even during COVID, we saw this, that the people that survived the lockdown, who handled the lockdown much better than others, are the ones who had these integrated communities. Whereas even for the well-to-do households, we found that those of us who live in these very private, exclusive places where you're driving into your garage, the depression, problems like depression, they were kicking in quickly. And then just the isolation, the ease with which information about extreme heat events will reach such people also become difficult. That if a person is not connected through social media, they are not watching the TV. If they are living in this community that is not well integrated, then they are more vulnerable to extreme heat and also flooding. There was a story that went viral when we had Hurricane Ian in the US, that a couple had gone to South Florida for their honeymoon, and they were living in this hotel. Of course, they were in their honeymoon and they were not interacting with other people. They were not watching TV. They were not on social media, and they had no idea that there was a hurricane in the area. So they only found out when they went downstairs the next morning and the hotel was deserted. There was absolutely nobody. So they're calling 911 and they're told it's too late. You can't get out. You need to find a concrete structure somewhere like the stairwell and you hide behind it. Thankfully, they were okay. But this actually goes to reinforce your point, George, that the human contribution to resilience, the strength that we bring when we have numbers cannot be rivaled. The ease with which information about, strategies that we can implement, the ease with which it can be transmitted by word of mouth is much, much higher than with the use of technologies. Or I remember Givens when we had a stakeholder engagement workshop and we had community members a year ago. They were not so keen on reading the dissertation. I don't even think they have the time and capacity to do that. So they were like, we want something that we can talk about very, very easily. Yeah, but moving on to another question that has been posted in the chat by Dr. Manduri, and thank you for posting that. This question is for you, Givens. Yeah, from a lab perspective, there's a lot of information about cost-effective and also sustainable construction materials that can be used for low-cost housing. I know in some countries they use affordable housing. From your experience and the experience of your institute, the institute that you work for, can you please help us understand the success rate of deploying those technologies in the real world? Yeah, what are some of the things? Yeah, I think that's enough. Please answer this.
Yes, I think that's a very candid observation. Again, when you are talking of the adaptability, of what you find as results in the lab to working into the real world. That is a function of so many attributes again. Because, for example, in here, when you are talking of housing, it's a bit different from what you might find when you're talking of for housing in other places where you have very big government schemes. The government comes in and makes houses for the community. But when you're talking of the East African experience, you are, as an individual, responsible looking for your own shelter, meaning looking for a place to live. Now, when it comes to when somebody is looking for a place to live here, the biggest factor that is being in consideration is the money in the pocket. Okay, so you find that becomes the leading factor. While when you are in the lab trying to research what might really help the people, you might be looking at all those kind of dimensions like sustainability. How does it affect the environment? How does it becomes repairable? And so many other factors. Now, it happens so many times that you might come up with results. Say you're coming up with a clay soil brick, which is very good in terms of insulation for those who are living here in Dar es Salaam. But whenever it becomes a little bit higher in terms of costs, as what the people or the communities used to, that will just end up in the lab. So when you're talking of the experiences that we have here, whenever you come up with a lab results, if you don't have the triangulation of your findings from the community, it will always fail. That is for one. But for two, you always need to blend, to customize your findings such that it actually considers very much of what is the most factor being considered by the community when it comes to building their homes. Now, in order to do that, you actually really needed to have what you call research by doing. Get out of your lab with your findings, go to the community, look at how will that technology you are bringing into the society might be workable in terms of how, if it's a brick, how easy is it, is that block when building the house? What is the cost, okay? Can it sustain or withstand the issues that are commonly found in those communities, like they always build using saline water, for example. They use scent, which is not up to the standards, and all those kind of dimensions. So if I'm to sum up, answering what Dr. Madhuri is saying, I feel as if there is much more to be done when it comes to tailoring what we find in the lab so that it really finds the way to the community.
Thank you, Engineer Muhina. So we'll start wrapping up. I'm going to invite each of you to give us some thought, to reflect on this question just very briefly. Based on the work that you're doing and the discussion we've had this morning, if you were to provide a recommendation for research, one research question that the community, an interdisciplinary community, needs to focus on going forward, what would that be? So I'll start with you, George, and then come to you, Dr. Muhina. What should our future research as an interdisciplinary community of people who are working in this space of climate change, resilient built environment, what sort of question would you propose we focus on?
Sure, thank you. Yeah, and thank you for a really interesting discussion as well. This has been really useful for me and really interesting. And I think to kind of go off of your last point in that discussion, I think that the most important thing to figure out is, I think we have in a lot of cases the technical solutions in place. We know from an engineering perspective what can be done to make buildings more resilient, more climate resilient. What we don't understand quite as well at the moment, or haven't been able to marry up quite as well, is how do you build those technical solutions into something that is culturally and socially accepted by communities, and the way to do that is to engage more effectively with people that have been affected. So I think the future focus should be how do we make sure that what we're doing meets the needs of the people that we're saying are the people that we're helping? Because I think that that's often lost in practice.
Thank you, George. How about you, Given?
Yes,
Call to action. What should we be researching going forward?
Yes, I think the perspective here in East Africa might be a little bit different, because most of the cities in East Africa, they are very fast growing, we are urbanizing very fast, but unfortunately in exploring manner. Now, if I'm to answer your question, if at all we want to focus on something that might have a bigger impact in terms of the community here in East Africa, and which is related to building the resiliency of our cities, then should be looking at the ways to tackle the urbanization wave so that we mainstream what we think works in terms of improving the resiliency of cities in East Africa. And for me, that should be the nature-based solution.
Yeah, thank you, Givens. So I think my call to action, I think we should do all these things through global collaborations. Thank you. I think going back to the example that you cited of the project that was implemented, Givens, I noticed that you had a partner in Ethiopia, another global South country, and then you had a partner in Europe, global North. Yes. So I see the future as predicating on us embracing this opportunity to collaborate across those regions, global North, global South, and global South. You talk about rapid urbanization. India is going through exactly the same experience, rapid urbanization. If there is an implementation or a pilot project of nature-based solution that is working in India, it can inform and advance what is happening in East Africa. And I will also venture to say that because the people who are hardest hit are the people who are social, economically disadvantaged, if it works in India, it can be adapted and it can help a low-income neighborhood in Pittsburgh. In the US or even in Europe, in UK, they are dealing with problems of extreme heat and extreme flooding. And it is the same. The poor, low-income households are being impacted disproportionately. So I think it's time for us to embrace opportunities such as those presented by the Global Council for Science and Environment and engage in more science diplomacy to help scale and accelerate the technologies that George is saying are already there. We know that they can work. They need to be adapted to be made more socially and culturally acceptable. And we can learn from the COVID vaccine for sure. The world came together, the researchers came together from academia, from the private sector, from car manufacturing, and they shortened the time it takes to deliver vaccines. So I'm very confident that if we partner better, if we partner smartly, if we partner in a business unusual way, we are going to shorten this time that it takes to make our buildings and our built environment more climate change responsive. So thank you so much for participating. I will hand back over to Dr. Manduri.
Thank you so much, Dr. Easter, Mr. George, and Engineer David. In fact, I mean, it is the time is short and there is a lot to discuss. And of course, the conclusion that you made, Dr. Easter, is something that is really that we need to work towards. Research topics are many, but yes, the prefix of global, whatever research we are doing, unless we go global, there would definitely be a gap and something like, we don't learn from others, but we try to do something in silo, and then it looks like kind of inventing wheel. Probably we can go to the next level if we take up. So it's very important. Go global in terms of research is the next calling thing. And of course, interdisciplinary and transdisciplinary is already in. People have started practicing it. Being in one domain, they are not just getting, they are not limited to just one domain, but across domain, we are already talking. And today's panel discussion was evident about it, that, we cannot be just talking about technology and ignoring socioeconomic aspect or community participation. So bringing things more meaningful I think it requires collaboration. It requires to go global. So that is the takeaway, great takeaway. And on behalf of Amity University, I open up my arm to collaborate with the building network basis research committee that we have, and look forward to learn more from you as to how we can have a strong collaboration, build on it, and we can talk together of what we are doing here and what you are doing there, and take the things more forward and the next level of research. So with that note, good morning, good day, and good evening to everyone. And we thank you once again for sparing your time.
Thank you. Thank you for having us.
Thank you all very much for
Thank you.
listening. Thank you.
Bye.
Very much.
Bye.
Bye.
Thank you. Bye-bye. Bye.